Good morning, everyone. I welcome you to the start of our Target Prelims 2022 Current Affairs program. First of all, I'm really sorry for the delay of 1 week. I was found COVID positive last Friday. So yesterday, like we have tested it twice now. Now I'm okay. So we'll be continuously having our classes. Now, before I jump onto today's class, today we'll be starting with science and technology, especially the space sector, in which we'll be talking about Indian efforts. Before I jump on to today's class, let me briefly explain you about the format of the class, the overall schedule that we have that we'll be following, and what are the different components of this Target Prelims Current Affairs program. I'll not take more than 5 minutes in explaining this portion. Now, this program would roughly go for 3.5 months, February, March, April, and May 15th, 15th May maybe, roughly for 3.5 months. In this month, in February, our focus is mostly on science and technology and economy. We'll try to finish entire science and technology and economy section in this portion, in this period. So science and technology, we're already starting today. I think from 1st of February itself, we'll be starting Economic Survey of India and Budget. So by February 10, what you'll also see is that your Economic Survey of India and Budget would be finished. Then we'll finish remaining science and technology, and we'll jump on to the remaining section of economy. March would be focused on environment and international issues. This means international bodies, programs, initiatives, all those things would be there. In March, we'll be dealing with this section, reports, WHO reports, and all those aspects would be covered here. Then in April, like some of it may also jump into April, but in April, our primary focus would be polity, schemes. Fine. And then some updates of this portion. And in the end, in May, we'll be dealing with miscellaneous things like art and culture, places in news, जो geography का map वाला question आता है, places in news, etc. Okay, so this will be the rough schedule. Many of you had been asking ki, what will be the flow of classes. I was waiting for the first class to explain you about the flow of classes. This will be the order in which we would be going. Okay. Now, there are students who are asking, for example, students are asking, how many classes will you take for environment and science and technology? Guys, it would depend on the duration of class. If I'm taking classes of 4 or 5 hours, aisa wala, so science and technology could be finished in 6 classes only. I need roughly 25 hours, 30 hours for science and technology. I need around 40 hours for environment. Okay, now we'll look at all these things one by one. But first, do you have clarity over what are the things that we are going to do? Isme koi doubt hai to bataiye. So Varsha is asking, sir, will analysis of economic survey will be uploaded on YouTube? Yes, the entire Economic Survey of India and Budget section would be uploaded on YouTube. So this is done. This is all understood. Now, coming to schedule of the classes in this program. Officially, we're supposed to have 3 classes every week: Friday, Saturday, Sunday. We'll have classes from 11:30 a.m. This is the start of the class. कब तक पढ़ाएंगे that will decide based on how much of things that we have to cover. At least we'll be having this class of 2.5 hours, but sometimes we may extend it for longer duration also. Okay, so when you're sitting for the classes at 11:30 in the morning, please ensure that you are heavily fed, so that आपका 1 बजे मन ना करे कि अरे चलो लंच का टाइम हो गया, थोड़ा हेवी ब्रेकफास्ट करके बैठना, ताकि even if it goes till 3 p.m. it would not be a big concern. So we'll have classes 3 days a week, but this week, because we're starting on Sunday, we'll take classes on Monday also, and after that we'll have our Economic Survey of India and budget series, जो कि YouTube पे सबके लिए चलेगा. So we would be continuing with that. Okay, now I'm sorry. So we're done with two things: the order in which we'll be covering things, the duration, the schedule of the program. Now, you would ask me, sir, what else do we have to do other than finishing all the booklets that you cover, all the tests that you take? So see, for subjects like science and technology, environment, biodiversity and climate change, economy, we tend to go into the fundamentals also. For example, today, when you'll study science and technology, the first topic of science and technology, you'll realize that my assumption is you do not know anything about space technologies. I'll be teaching you everything from the basics. Same would be the case with environment, biodiversity and climate change. Here, very minimal things you have to do at your own. For example, in case of science and technology, I'll ask you to read class 9 and class 10 NCERT, which is a very simple book. All of you should be able to read class 9 and 10 NCERT of science and technology. In the same way, in environment, biodiversity and climate change, I'll ask you to read 1 or 2 chapters from some random books. Otherwise, these topics would be done very exhaustively in class, along with its current affairs. Third, economy. In economy, I expect you to know basics. Like, it wouldn't be possible for me to spend a lot of time in explaining you what is the difference between GDP and GNP. Those things would not be feasible for me to cover in the classroom. So here you can refer any standard book, NCERT एक कर लीजिए, या फिर not and or. There's a very small book on economy by Shankar Ganesh, Indian Economy by Shankar Ganesh. Or many of you may refer to Vivek Singh sir's notes. Vivek Singh sir's notes वो थोड़े ज्यादा होते हैं because he is covering all the current affairs. He'll update it with Economic Survey of India budget and all. But वो तो हम अपने प्रोग्राम में कर ही रहे हैं. इसलिए I prefer some basic book like NCERT or Shankar Ganesh. But even if you are doing Vivek Singh sir's book, that's a very good book. You can do that. If you're going through the Shriram's economy book, that's also a very good book. All those books are okay, but I do not need that much of things. I'll cover a lot of things in the class only. So आप अगर basic कुछ cover करके रखेंगे, that would be good. So for science and technology, environment, biodiversity and climate change, and for economy, आपको बहुत ज्यादा कुछ नहीं करना है. But for subjects like history, geography, I expect you to do these things at your own. These are not like something that we cover exhaustively in current affairs program. So history and culture, geography, you'll do at your own. International bodies, again, you do not have to cover anything. International bodies, we would cover in detail. Polity or geography mein, our focus would only be on current affairs. Our focus will not be getting into basics. Like, it's not possible that in a current affairs program, I explain you what fundamental rights are and in which article what is mentioned. I cannot cover the whole Lakshmikant or D.D. Basu again in this section of the class. So these things, science, environment, economy, international bodies, we will cover thoroughly. Budget, history, geography, polity, or let's say governance related things. I'm only going to cover current affairs portions related to that. तो अपने मटेरियल से आप ये thoroughly पढ़ सकते हैं, उसके लिए आपको कुछ बेसिक चीजें और पढ़नी पड़ेंगी. Fine. Now let me quickly come to the format of the classes. Or when we cover current affairs, when we're studying current affairs, the mistakes that people may do is that they tend to go through their basics and then they go through some weekly current affairs magazine or monthly current affairs magazine and somehow feel like their preparation is complete. No, you should always integrate your current affairs preparation with your basics preparation. When you're studying the basics of PSLV, GSLV, at that time you should also study the current affairs portion related to it. And this is what we'll try to do. We'll be covering, like today when we start with science and technology, we'll cover fundamental topics, and you'll see that in every topic, whatever has happened over the last 1 to 3 years, depending on how relevant that is for your exam, we would be covering those portions here, we'll be covering those details here. So what would be the format of the class? In every class, you will get a booklet. Like, for example, today you have space booklet. For those of you who are only watching it on YouTube, please go to the description of this video. There you will find a Telegram channel link where we have uploaded today's classes. So we'll have a booklet which will be our primary study material in next 3-4 months. In every class you'll get this booklet. Other than that, in every class you'll also get a question set. For example, on today's booklet, I've already provided you 50 questions. So you'll have this booklet, you'll have this question set. We'll try to cover this in one class. And then once a topic is completed, like let's say when science and technology is substantially done, we'll also have weekly tests for that. Okay, so we'll do 3 things. We'll study those topics in the classroom. We will do a lot of objective questions in every class. I'll try to solve at least 25 questions. Like today, we'll try to ensure that हम कम से कम ये 50 questions जो आज मिले हैं वो solve करें. And then you'll also have a weekly test, a test at the end of week. Okay, this is for science and technology. This will be the format of class for science and technology. But when we'll come to, let's say, polity, there the pattern would be a bit different. When we are studying polity, first what I'll ask you is, I'll give you some assignments that you go home today and cover, let's say, chapter 1 to 7 of Lakshmikant. This you'll have to do at your own. You'll cover those things in at your home. In class, we'll first solve some MCQs on this basic portion. Then we'll cover current affairs booklets related to this section of the polity, like chapter 1 to chapter 7 of Lakshmikant se related, jo bhi current affairs hoga, we'll solve that. And then, because in this section, which section is this? This is the section in which I want you to know something already. Like for science environment, I'm going with the basics. So I'll first do the booklets, then questions, and then weekly tests. But in the topics like polity, I'll first ask you to study the basics. Then we'll solve some MCQs on those basics to revise those basics for you. And then we'll come to current affairs booklet and then question set. Or finally, you'll have your tests. I hope you have clarity on how we would go in different sections. For science and technology or for environment, order would be different. We'll first study, then we'll solve questions, and then weekly test. For certain other subjects, for geography or for polity, the pattern would be slightly different. Okay, so any doubts? Let me see the chats that you have. What about art and culture? Please once tell. Art and culture ka current affairs portion I'll be doing. Like in this current affairs program, I'll not promise that I'll cover entire art and culture, but the current affairs portion of art and culture we will definitely do. Sir, how many booklets are there for science and technology? Around 10 booklets. Governance, देखो governance में ना जो schemes, programs, vulnerable sections, related things हैं जो prelims के लिए important है, those would be covered. Is this course paid? Yes, this is a paid course. Tomorrow it's the first class, so we generally, whenever we start a topic, we first put it on YouTube to ensure that more people would know about this. So please make this course a little affordable. It's too much for me. I would be highly obliged to attend your classes. Buddy, the course fee is only 12,000, and in 12,000 you'll get around 100 classes, 70 classes. So I think थोड़ा सा fee कम करना challenging है हमारे लिए. Jai Shri Ram is writing, I'm a HEXA student. Welcome, Jai Shri Ram. What about history classes? No, history. This is a current affairs program. We won't be taking history classes. Sir, can we get 2-3 booklets together? No, you would not be able to get 2-3 booklets together. I keep updating these booklets till a day before classes. तो जब भी classes होंगी उससे पहले आपको booklets मिलेंगी. Online or offline, it's available in both online and recorded mode. Offline we are not doing right now. If in 7 days government would allow, we would start taking offline classes also. Like I'm sitting in my I'm standing in my classroom with a empty hall in front of me. So I would want that students come to the class and take these classes accordingly. Take these classes in front of me. Sir, will the weekly test contain static portion? Yes, weekly test would contain static portion also. I'll try to ensure that polity का, geography का, history का portion आपको टेस्ट के सिलेबस में डाल के आपसे कंप्लीट करवाया जाए. Okay, so should we start with today's class? Sir, apart from this, we need not do any other thing for current affairs. Yes, that's my assurance for you. Let it be my responsibility to go through all the current affairs material that exists, all the newspapers, Down to Earth magazine, PIB and everything. You finish this portion. See, today only for Indian efforts in space, I have given you notes of 50 pages. You will see that each and every small current affairs has also been updated. Let it be my responsibility to go through whatever is there in the market, whatever is there in the various standard books, whatever is there in the newspapers, and you finish it. I assure you of this, when you will be writing your exam, when you will be attempting your preliminary examination paper, your problem would not be less coverage. Your problem would be, sir ने इतना सारा पढ़ाया, हम वो सब अच्छे से रिवाइज ही नहीं कर पाए. So start focusing on these materials, start going through these materials, start revising them right now, because till May 15 or May 20, we'll keep taking classes, we'll keep updating these things. So you'll keep getting a lot of material every week. So it's very important in this process that आप इसको बार-बार revise कर पाए. Focus only on this and your static portion of the syllabus. Anubhav is asking, sir, last year की तरह questions environment के science and tech के. Last year I had run a series called RTFQ, revised through 500 question series for environment. We'll do that this year, but it would we'll take a call whether we want to do those questions in the classroom or whether we want to run a separate series. For example, in today's class, I have already given you 50 questions. So ऐसे जब 10 classes होंगी science के, you'll already get 500 questions. So when you will already do those 500 questions in the classes as part of the program, perhaps running a separate RTFQ would not make sense. So if we are not doing it as part of the class, then we'll run an RTFQ. But for science, for environment, for economy, I assure you, we will be solving at least 500 MCQs, which would include relevant past year MCQs as well as the new ones. हाँ, करंट अफेयर्स के लिए और कोई मैगजीन नहीं पढ़नी है. Online classes are recorded or live? Arpit, online classes are available in the live form. और उसके बाद, once the live classes are done and you want to watch it in the evening, you also have the recorded videos available. So online classes are both in the live form and recorded form. Like today we are taking live classes. Tomorrow from our portal we'll be taking this live class. And then after the class, if you're not able to watch it in that duration in the live session, you'll be able to watch the recorded session also. Okay, Gridhar Samineni is asking, sir, what about sports news? Arey, last year 2-3 questions sports ke aa gaye. So see, ROI on sports would be very less, but still towards the end of the program I'll try to cover some important sports update. But last year 3 सवाल आए हैं, but पिछले 10 साल में तो एक भी सवाल नहीं आया था ना. तो making me go through कि टेनिस में ये हो रहा है, फुटबॉल में ये हो रहा है, क्रिकेट में ये हो रहा है, would not make a lot of sense. Okay, so please do not expect कि I'll go through all the sports related things. That would be challenging for me. That would not be possible for me. Sir, what should I read, Indian Express or Hindu? Anyone would do. Anyone would do. Okay, so let's start with today's class then. Sir, PDF on Telegram channel is for today's classes. Yes, it is for today's classes. Okay, let's start with today's class. Today you have got 2 material. one is target the booklet one, and I think other one must be the question set one. These are the two things that we want to finish today. Okay. We are starting with science and technology. Now, I'm sorry. We're starting with science and technology, and science and technology, I'm starting with one of my most favorite topic, space. Why is space my favorite topic? It's because before I had studied space, before I had taught space, I used to think that space is something or rockets or satellite is something जो समझना बहुत challenging रहेगा. From my childhood I had been hearing this कि ये rocket science थोड़ी है, as if rocket science is very very complicated. So through this class, through today's class, I'll help you understand that space is a very very easy topic to prepare for civil services examination if you understand its fundamentals. And most of the time, I have given you past year questions also among those 50 questions. The questions that are asked from space also are from basics. Other than, like, sometimes they've asked questions on PSLV, GSLV and all those kind of things. Other than those things, most of the questions are from basics of space science and technology. So in space, in today's class, we will divide our classes into various sections. In the first part of the class, we'll deal with the basics of satellite orbits. In satellites orbit, we'll talk about various kind of orbits, low Earth orbit, medium Earth orbit, geosynchronous orbit, geostationary orbit, elliptical orbits, and so on. Then we will talk about rockets of ISRO. Rockets, PSLV, GSLV, sounding rocket, GSLV Mk III. Rockets are the vehicles which are used to take satellites to the orbit. Satellites are the thing which revolve around Earth. So moon is a satellite of Earth. Rocket is something that will take satellite to that point. So जैसे हम GSAT satellite, बहुत सारे satellites Earth के around revolve कर रहे हैं. Rockets would be something that will take satellites to those orbit. So first we'll talk about ISRO rockets, various rockets that ISRO has. Then we'll talk about ISRO satellites or spacecrafts. We'll talk about communication satellite. We'll talk about Earth observation satellite. We'll talk about how GPS functions in India's NAVIC system, how NAVIC is playing a role in improving the situation in the country. Then we'll talk about some miscellaneous projects of ISRO. ISRO's interplanetary mission. We'll talk about Mars orbiter mission. We'll talk about Chandrayaan. We'll talk about Chandrayaan 2. We'll also talk about Chandrayaan 3.0, which is being planned, how all these things function. We'll be dealing with that. Then some other recent achievements by ISRO, like ISRO is trying to implement quantum key distribution thing. So in that, what success has been made. Important personalities of Indian space program. Recently, S. Somanath has become the new chairperson. Then we'll talk about Vikram Sarabhai also. Then there are some new institutions which have come up to promote privatization and commercialization of space sector. Isme we'll talk about New Space India Limited, InSpace, Indian National Space Promotion Authorization Center, and Indian Space Association, which is something that has been launched recently. October, May, this satellite has been launched. And then finally, we'll talk about reforming space sector. That section is mostly relevant for mains examination, but then I realized that those are the initiatives which are taken by ISRO. So UPSC may ask in preliminary examination which of the following initiative has been taken by ISRO to reform the space sector recently, and that's why I've included that portion also. Now, already Shivam is asking, sir, what about international satellites and missions? आएगा ना, space का second booklet भी आएगा. देखो, you'll have 3 booklets. One on space Indian efforts that we are doing today. Second, on space international efforts, where we'll talk about what NASA is doing, what Japan is doing, what other countries, what China is doing. Then we'll have a booklet on astronomy. In astronomy, we'll talk about stars and galaxies and minor planets and dwarf planets and all those kind of things. We'll be dealing with those aspects. Black hole house, black hole functioning, we'll be dealing with those aspects. Okay, so let's start with today's class. Okay, चलिए सब लोग ध्यान से पढ़ेंगे, because After every topic, we'll be solving some questions. So if you want to note down things, please note it down. All of you who are watching it online, please, in the description, there's a Telegram link. There's a Telegram link of my current affairs channel. There, both the PDFs are available. For those of you who are not part of current affairs program, both these PDFs, the booklet PDF as well as the question PDF is available. Please download it, have it in front of you, and then we'll start the class. Orbits. So the first 1 hour that we are spending, if you understand each and everything properly in this first 1 hour, next 3 classes would be a cakewalk for you, because all the fundamentals that we teach here would be used in next 3 classes. So very carefully go through each one of this topic. Okay, so let's first start with understanding of what is orbit. Very basic level, what is orbit? So in very simple language, this is Earth. Moon revolves around Earth. Moon is revolving around Earth. The path which Moon is taking to revolve around Earth is Moon's orbit around Earth. So this is orbit. Moon is a natural satellite. हम खुद बहुत सारी satellites launch करते रहते हैं. For example, Earth Observation Satellite 1. ISRO launched it very recently. It's a satellite which revolves around Earth. The path that this satellite takes is this satellite's orbit. Do you understand what orbit is? है ना? यहाँ पे एक complicated definition दिया हुआ है. An orbit is the curved path, because orbit is not straight line. It's a curved circular path or elliptical path that an object in space, such as planet or moon, star, etc., take around another object due to gravity. So curved path which moon is taking around Earth, or let's say हम यहाँ पे sun बना देते हैं. Earth is also revolving around sun. Earth revolves around sun in an elliptical orbit, or so this is also orbit of Earth. This was orbit of moon. Moon के around क्या घूम रहा है? हमारा चंद्रयान घूम रहा है. Chandrayaan 2 is revolving around moon. Chandrayaan 2 हमने recently launch किया था. That's revolving around moon. That is orbit of Chandrayaan 2 around moon. So what is an orbit? An orbit is the path taken by a large body while revolving around, or a path taken by a small body while revolving around a large body due to the force of its gravity. That is orbit. Now, gravity plays a very important role in deciding the orbit, or in deciding in what orbit would I be. So let's say this is Earth. Okay, gravity and speed of the satellite is the topic we are deciding. Let's say this is Earth. This is a satellite which is revolving around Earth at a radius r1. This is a satellite which is revolving around Earth. This is another satellite which is revolving around Earth at a radius r2. Okay, this is satellite 1. This is satellite 2. We want to understand which satellite will have higher speed. We want to understand which satellite will be having higher speed. It is revolving, so it is having some speed. Which satellite has higher speed? यहाँ पे I'm going to put some mathematical formulas, but you people do not have to worry about those mathematical formulas. Those mathematical formulas are my concern. उससे जो conclusion निकलेगा ना, that is something that you'll have to remember. So what will be the speed of the satellite in this orbit? What will be the speed of satellite in this orbit? Or what will be the speed of satellite in this orbit? Will the speeds be same? No. Which one would have higher speed? Which one would have lower speed? Let us not speculate. let us understand it. देखो, what is the force of gravity? Gravitational force कितना होता है? Force of gravity is equal to G m by r square, where m is the mass of the larger body, small m is the mass of the smaller body. तो यहाँ पे m is the mass of earth, small m is the mass of the satellite. इतना फोर्स लग रहा है किसी भी सैटेलाइट पे, r changes accordingly force changes. तो satellite which is further away, r is in the denominator, it will the gravitational force that would be applied on it would be much lower. यहाँ पे gravitational force would be very high, यहाँ पे it will be lower, यहाँ पे it will be much lower. If the satellite was revolving in this orbit, then it would have been further higher. तो आप अर्थ के जितना पास रहोगे ग्रेविटेशनल फोर्स उतना ज्यादा रहेगा. दिस फॉर्मूला इज टेलिंग यू दिस. Okay, and when a body is revolving around earth, when a body is revolving around earth, or when a body is revolving around anything, तो एक उसपे centripetal force लगना चाहिए to make this revolution happen, where v is the speed at which it is revolving, r is the radius at which it is revolving, and m is the mass. Now many of you may not understand these formulas, please ignore it. हम अभी जो कंक्लूजन पे आ रहे हैं ना वो ध्यान रखना, दैट इज इंपॉर्टेंट फॉर अस, दैट इज समथिंग दैट विल राइट इन आवर बॉक्स. हमें नोट्स मिला है, नोट्स में भी आई हैव प्रोवाइडेड यू एन एम्प्टी बॉक्स. द कंक्लूजन इज समथिंग दैट वी वांट टू राइट इन आवर बॉक्स. कंक्लूजन इज इफ यू सॉल्व दिस इक्वेशन यू विल गेट v इज इक्वल टू अंडर रूट जी एम बाय आर. देखो ये r से ये कट जाएगा तो v स्क्वायर इज इक्वल टू जी एम बाय आर, v इज इक्वल टू अंडर रूट जी एम बाय आर. This is something that you should always remember. This is one basic thing that you should always keep in mind. What v is equal to under root g m by r, where g is the gravitational constant, m is mass of earth. In our case we're talking about earth because earth के around revolution हो रहा है, and r is the radius. Now by this you'll understand that सैटेलाइट का साइज कितना बड़ा है, इट विल नॉट डिसाइड हाउ, सैटेलाइट का वेट कितना ज्यादा है, इट विल नॉट डिसाइड एट व्हाट स्पीड इट इज रिवॉल्विंग अराउंड अर्थ. बिकॉज स्पीड में क्या किसी भी तरह से सैटेलाइट के वेट का कुछ रिलेशन आया नहीं. मून का वेट कितना है, इट डिड नॉट डिसाइड एट व्हाट स्पीड इज इट रिवॉल्विंग, इट इज रिवॉल्विंग अराउंड अर्थ. नाउ लेट मी ड्रॉ अर्थ अगेन एंड सैटेलाइट 1, let's say it's revolving in a circular orbit at a distance r1. Satellite 2, it is revolving at a distance r2. Which will have higher speed? Which one would have higher speed? Satellite 1 or satellite 2? Sandeep will answer. Satellite 1 will have higher speed क्योंकि इसका रेडियस कम है. अंडर रूट जी एम बाई आर, v is equal to under root g m by r. g is the gravitational constant, m is the mass of earth. तो ये तो सैटेलाइट 1 सैटेलाइट दोनों 2 के लिए दोनों r चेंज हो रहा है. r किसका ज्यादा है? r सैटेलाइट 2 का ज्यादा है. अगर डिनोमिनेटर ज्यादा है तो स्पीड कम होगी. डिड यू अंडरस्टैंड दिस? पक्का? और conclusion that you should remember is that your speed is inversely proportional to what? Radius. Because ऊपर तो g और m तो कांस्टेंट ही है, मास ऑफ अर्थ बदल नहीं रहा, ग्रेविटेशनल कांस्टेंट बदल नहीं रहा. g is inversely proportional to स्क्वायर रूट ऑफ रेडियस. मतलब अगर रेडियस ज्यादा है आपका स्पीड कम हो गया. This is the first conclusion that you should have with you. Okay, Nizamuddin Raza sir, what about Hindi medium students, sir? Sorry guys, I teach in English medium only. Okay, anyways, did you all understand this? Do you have clarity on this? One conclusion that we have come up with is speed of a satellite is inversely proportional to square root of r. यहां पे सबसे पहले इस चीज को समझो. What will you write? You'll write that speed of the satellite is inversely proportional to तो आप जितना पास रहोगे, जिस बॉडी के अराउंड आप रिवॉल्व कर रहे हो, आप उतना तेज चलोगे। आप जितनी दूर रहोगे, आप उतना स्लो चलोगे। दिस इज द कंक्लूजन दैट, फॉरगेट अबाउट द फॉर्मूला, अगर आपको समझ में नहीं आया इग्नोर इट। बट अर्थ के अराउंड सैटेलाइट रिवॉल्व हो रहा है, इट विल बी, if it's near earth it will be revolving very fast, if it's far away from earth it will be revolving slowly. Is this understood? This is one conclusion that you should keep in mind. What this leads to is this: अर्थ, एक सैटेलाइट जो सिर्फ 500 किलोमीटर ऊपर है अर्थ के, और एक सैटेलाइट जो 36,000 किलोमीटर ऊपर है। 500 किलोमीटर। दिस सैटेलाइट विच इज ओनली 500 किलोमीटर अबव, एक तो ये बहुत हाई स्पीड में चल रहा है, सेकेंड द डिस्टेंस दैट इट हैज टू कवर इज वेरी लेस व्हेन कंपेयर टू दिस बिगर सैटेलाइट। Bigger satellite has a much longer orbit. It has to cover higher distance and it's moving slowly. It has to cover lower distance, it's moving very fast. तो क्या होता है ना, at this height, roughly in 90 minutes, it completes one orbit of Earth. आज हम देखेंगे बहुत सारी सैटेलाइट्स जो लोअर अर्थ ऑर्बिट में है, जो अर्थ के बहुत पास में है, only 300, 400, 500 kilometers away. They can complete one revolution of Earth, one orbit of Earth in very small time. Whereas the satellites which are far away, satellite which is let's say at a height of 36,000 kilometers, it completes one revolution in 24 hours. आप उसके भी बियॉन्ड चले जाइए, सैटेलाइट्स which may be revolving at 50,000 kilometers की हाइट पे, they will complete one revolution in much larger time, 24 hours से भी ज्यादा। तो जो बहुत पास में है, they keep revolving Earth, 2 घंटे बाद वो एक चक्कर अर्थ का लगा के वापस आ जाएंगे। Satellites which are there in low Earth orbit and satellites which are there in high Earth orbit, they will take a lot more time. I hope everyone is able to understand. अजय हमारी वीडियोग्राफी टीम से, लगता है इनको भी आज स्पेस समझ में आ जाएगा। अजय समझ में आ रहा है? सैटेलाइट जो पास में होगा, इट विल बी रिवॉल्विंग फास्टर, और उसको कम डिस्टेंस कवर करना है तो इट विल बी टेकिंग मच लेसर टाइम। तो लो अर्थ ऑर्बिट में टाइम बहुत कम लगता है, हायर अर्थ ऑर्बिट पे टाइम ज्यादा। यहां पे अगर सैटेलाइट रिवॉल्व कर रहा है, इट विल टेक मोर टाइम बिकॉज ज्यादा डिस्टेंस कवर करना है टू कंप्लीट वन ऑर्बिट, एंड वो स्लो भी चल रहा है। उससे ऊपर जाओ, वेलोसिटी कितना होगा? √gm/r। आर बढ़ता जा रहा है, आर बढ़ता जा रहा है, उससे क्या हो रहा है? स्पीड कम होती जा रही है, और कवर कितना करना है? 2πr। तो डिस्टेंस ज्यादा कवर करना है, स्पीड कम करना। दिस वन कंक्लूजन एकदम भूलना मत जीवन में कभी भी। इससे एक और इंटरेस्टिंग चीज आपको समझ में आएगी। दिस इज नॉट समथिंग विच इज वैलिड ओनली अराउंड अर्थ, इट इज ऑल्सो वैलिड अराउंड सन। सन के पास सबसे पास क्या है? मरकरी, वीनस, अर्थ, मार्स, जुपिटर, सैटर्न, नेपट्यून, दे आर ऑल रिवॉल्विंग अराउंड सन। सबसे कम टाइम कौन ले रहा होगा? मरकरी। सबसे तेज कौन चल रहा होगा? मरकरी। सबसे तेज मरकरी चल रहा है, फिर वीनस, फिर अर्थ। देख लीजिए, याद नहीं करना है कौन सबसे कम टाइम लेता है, कौन सबसे ज्यादा टाइम लेता है, याद नहीं करना है। अंडरस्टैंड द लॉजिक। What is the force which is making Earth rotate around Sun? It is the gravitational force. Gravitational force is larger here, smaller, smaller, smaller. अब जितना अर्थ सन से दूर जा रहे हो, सन का ग्रेविटी उतना कम होता जा रहा है। Radius is considered from the center of the earth or from the surface? Radius is from the center of the earth, always center of mass से होगा। ओके फाइन, ये क्लियर हो गया पहला एस्पेक्ट। तो ग्रेविटी एंड स्पीड ऑफ द सैटेलाइट, किसी भी बॉडी से आप जितना दूर जाते जाओगे, ग्रेविटी इज gravitational force is Gm/m/r², एंड इससे ही हमारा आता है स्पीड ऑफ द सैटेलाइट इज √Gm/r। फर्स्ट कंक्लूजन, प्लीज आप देखेंगे आगे की जितनी भी क्लासेस होंगी ना, सब में आई कीप यूजिंग दिस थिंग। तो ये फॉर्मूला भी नहीं लिखना है आपको, आपको क्या लिखना है, अगर आप अर्थ के पास हो ज्यादा तेज चलोगे, अर्थ से दूर हो धीरे धीरे चलोगे, ये समझ के रखना है, ये याद रखना है। ओके, नाउ अब हाउ डू वी प्लेस सैटेलाइट्स इन ऑर्बिट? How do we place satellites in orbit? Let's understand this. See, Earth है, the rocket, let's say this is my rocket, the rocket will take my satellite to this height and will launch the satellite. Now, when rocket launches the satellite may go in a circular orbit. Circular orbit मतलब उसका रेडियस सेम रहेगा. Satellite may go in a elliptical orbit, or satellite may fall back on Earth. But in what situations does it happen? Let's understand this. First, let's understand how is satellite revolving around Earth. Satellite revolve कैसे, with what is the force that is making satellite revolve around Earth? जैसे sun है, वो अर्थ है, वो सन के अराउंड कैसे रिवॉल्व कर रहा है? What is the force that is keeping it revolving? हमारा पंखा तो ऐसे घूमता नहीं रहता विदाउट इलेक्ट्रिसिटी दिए हुए. How is Earth able to revolve around sun? Earth is able to revolve around sun because of the gravitational force. Now, what happens? और यहाँ पे एक सैटेलाइट की बात करते हैं. What happens to a satellite? Let's say we take our satellite here. Why does it start revolving? If you are launching it in this direction with an initial speed s. किसका फोन बज रहा है भाई? बाहर? Let's say we launch the satellite with a speed here, with a speed v here. Now, satellite is supposed to go in this direction. Gravity is pulling it in the downward direction. तो उसका resultant speed क्या होगा? Resultant direction of movement क्या होगा? Resultant direction of movement would be somewhat on this side, right? ऐसे ही इस point पे the satellite is supposed to go on this side. Gravity is pulling it downwards. तो इसका resultant movement would be somewhat on this side, on this side. In this way, it will keep revolving. Because of its existing inertia, because it's moving in this direction, it will try to go ahead, but Earth उसे थोड़ा अपने पास बुलाएगा. So rather than going in a straight line, it curves. Rather than going in a straight line, it curves. Rather than going in a straight line, it curves. And because of this Earth's gravity, it keeps revolving around. The satellite keeps revolving around Earth. Same is the case with Earth. अगर आज अर्थ रुक जाए, it will fall into sun. Something like this. Let's say this is Earth and this is a satellite. If you leave a satellite here and do not launch it in horizontal direction with a particular speed, the satellite, because of Earth's gravity, will fall on Earth. It is able to revolve only if it has this initial speed. Otherwise, it won't be able to revolve. It's able to revolve only if it has this horizontal speed. Did you get it? अगर आप उसे जीरो स्पीड पे किसी भी चीज को आप अर्थ से 200 किलोमीटर ऊपर ले जाके बस छोड़ दो, it will fall back on Earth. That's something that happens in case of a ball. If you take a ball up and leave it, it will fall back on Earth. Earth's gravity will pull it. But अगर आप उसे एक पर्टिकुलर स्पीड से ज्यादा स्पीड से लॉन्च करोगे, तो the system would be, it will try to go in this direction, Earth will pull it in this direction. यहाँ पे क्या होगा? It will come here, it will come here. देखो, when it's here, it's trying to go in this direction, Earth is pulling towards it. What is happening? वो थोड़ा सा अर्थ की तरफ मुड़ जाता है. but because of Earth's curvature, it is at an equal distance from Earth center, and it keeps revolving. Did you understand this? To launch a satellite, you will have to launch it with some horizontal speed. First is this. If अब now देखो हमने क्या पढ़ा था, v is equal to under root gm by r, ये पढ़ा था. If you launch a satellite with this speed, if the initial v is equal to that, let's say, let me call it v1. If it is equal to under root gm by r, it will keep revolving in a circular orbit where its distance from center of the earth is r. If you launch it with a speed less than under root gm by r, if you launch it with a speed if let's say you're launching it with an initial speed v2 which is equal to, which is less than under root gm by r, in this case what would happen? It will eventually fall on earth. Why? Because earth का gravity उसे ज्यादा अपनी तरफ खींच पा रहा है rather than its initial speed which is taking it in this direction. So if v is equal to under root gm by r, it will revolve in a circular orbit. If v is less than under root gm by r, it will fall. If v is 0, so it is less than under root gm by r, it will fall back on earth. But what if v3, let's say, is more than under root gm by r? अगर आप इनिशियली इसे लॉन्च कर रहे हो एंड इफ इट्स स्पीड इज मोर देन अंडर रूट जीएम बाय आर, इन दैट केस देखो इसका हॉरिजॉन्टल स्पीड ज्यादा है, हॉरिजॉन्टल इनर्शिया ज्यादा है व्हेन कंपेयर्ड टू ग्रेविटी. ग्रेविटी इज ट्राइंग टू पुल इट टुवर्ड्स अर्थ बट हॉरिजॉन्टल मूवमेंट इट वुड बी हायर, so rather than it remaining in a circle, it would go in a ellipse. Did you understand? So there are some bodies, you will take them up and launch it ऐसे थोड़ा धीरे से, they'll fall back on earth. Like if you go to a big tower and throw a stone, stone eventually falls back on earth because इतनी ज्यादा तेज नहीं फेंक पा रहे हो आप. It will fall back on earth. If you launch it with a speed of at least under root gm by r, it will revolve around earth. If the speed is exactly under root gm by r, it will revolve in a circular orbit where its distance from earth is always r. If you launch it with a speed higher than under root gm by r, its horizontal movement is higher. Horizontal movement is higher, so it will go in an ellipse. Eventually gravity will take on and it will go back here, and it goes like that. Fine. I hope when a satellite goes, how are satellite placed in orbit? Circular orbit versus elliptical orbit. अगर speed कम है, it will fall back. अगर speed is under root gm by r, where r is this radius, if the speed is under root gm by r, then it will go in a circular orbit. If the speed is more than under root gm by r, it will go in a elliptical orbit. How is satellite launched? वहां पे उस height पे जाने के बाद, how will it be taken to that height? We'll understand that. But after our rocket takes the satellite to a particular height, how will it be launched? Will it fall back? Will it go in a circular orbit, or will it go in an elliptical orbit? I hope you have that clarity. सबको पक्का. Okay, there are some material. There are some doubts. Let me take this doubts. Sir, this time separate course on science and tech as previous year. हाँ आएगा. Separate course on science and technology would also come. Can Hindi medium students also take this class or not? Hindi medium students, like if they can understand the way I'm teaching right now, they can take this class. If they are not able to understand this, they would not be able to. This is a classroom program and online. This is both classroom and online program. Sir, how the initial velocity is sustained? Sir, due to gravitational force, Earth can fall into sun. What force is the reason for? tangential movement not resultant circular elliptical path. Is satellite only need initial speed, after that it's revolving only due to, हाँ विकास सिंह जी, satellite only needs this initial speed, after that it is revolving at its own. Satellite does not need energy to revolve around earth. देखो अर्थ को कोई एनर्जी चाहिए क्या सन के अराउंड रिवॉल्व करने के लिए? नहीं, अर्थ इज रिवॉल्विंग अराउंड सन और मून इज रिवॉल्विंग अराउंड अर्थ. मून रिवॉल्व्स, क्या मून में कोई इंजन लगा है? नहीं, इट इज अर्थ्स ग्रेविटी. इन द सेम वे व्हेन वी लॉन्च अ सैटेलाइट, टू टेक सैटेलाइट देयर, रॉकेट में हमारे इंजन्स होंगे which will take satellite to that height away from earth's gravity. But once the satellite is launched, it will keep revolving around earth in that orbit. Now one student has asked कि sir how is this speed sustained? How is this speed sustained? देखो इस चीज को समझो. सैटेलाइट यहां है, अर्थ नीचे है, अर्थ is pulling it in this direction, gravity is pulling it in this direction, satellite is going in resultant this direction, right? अब देखो when satellite has come here, it is because of earth's gravity it has gained this vertical motion. Initial motion was this. How has it come to this motion here? Because of earth's gravity. But now earth's gravity is pulling it in this direction, so you will see that it will keep losing its ये वाला direction का motion, it will keep moving in this direction. So it is earth's gravity which is ensuring that its direction of speed, its velocity keeps changing. It is earth's gravity, nothing else. हम कैसे revolve कर रहे हैं? हम sun के around revolve कर रहे हैं, earth is revolving around sun, it is because of sun's gravity, nothing else. Okay. आते impact of other celestial bodies. Sir, can I take admission online class and after opening of offline classes by paying difference? Yes, you can do that, Ritesh. Whatever you are asking is true. You got this. How satellite would be launched in a circular orbit, how it will be launched in an elliptical orbit. ये सबको समझ में आया है? Okay. Now, अब उस ऑर्बिट में स्पीड क्या होगी सैटेलाइट की? दिस वी हैव ऑलरेडी स्टडीड. देखो स्पीड क्या होती है कहीं पे भी? वेलोसिटी इज अंडर रूट जीएम बाय आर, राइट? तो इन अ सर्कुलर ऑर्बिट आर इज ऑलवेज सेम, तो स्पीड इज कांस्टेंट. आर इज ऑलवेज सेम, जी और एम तो सेम है. जी इज ग्रेविटेशनल कांस्टेंट, एम इज मास ऑफ अर्थ. आर इन अ सर्कल, आर इज ऑलवेज आर, बट इन एन एलिप्स आर इज चेंजिंग. This distance is different from this distance, is different from this distance, so its speed would also be changing. In a elliptical orbit, the speed would be changing. Let me take an example. Earth, elliptical orbit. इस वाली चीज को समझो. Here distance is something else, r1. Here distance is something else, r2. Here distance is something else, r3. Here distance is something else, r4. Will speed change? When it's very close to Earth, it will be moving fast. But as it moves away from Earth, when r is increasing, it will slow down. When it's furthest up from Sun, its speed would be the lowest. But as it starts going close to Earth, its speed will increase. It will be very fast. When it's near Earth, it's very fast. When it's far away from Earth, it's very slow. ये बात सबको समझ में आ गई? अच्छे से समझ में आई है? Okay, तो speed in case of circular orbit, if this was Earth and this was my circular orbit, which was always at a distance r, speed would always be under root gm by r. But if it's an elliptical orbit, speed would keep changing. Anmol is asking, sir, speed at a radius can't be changed. अच्छा, there are some doubts. Let me एक करके देखने दो. as you said that G will take over and eclipse will change to circular, then circular exchange in satellite will fall. I am not able to understand your question, RT. Anmol is asking, sir, speed at a radius can't be changed even with technology advancement. See, speed at a radius can't be, ऐसे समझो कि if gravitational force is going to play its role, देखो, you may have a satellite which is moving at a much different speed, but then that satellite will have its own engine, and its engine will decide at what speed it is moving, how it is tackling gravity and all. But if you have to revolve around a body on the basis of its gravity, it will not change. क्या अर्थ का स्पीड ऑफ रेवोल्यूशन अराउंड सन चेंज होता है? नहीं, वो चेंज तभी होगा जब सन की ग्रेविटी बदले या अर्थ का रेडियस बदले, अंडर रूट जी एम बाय आर, या तो सन का मास m बदले या अर्थ का रेडियस r बदले, अदरवाइज नहीं बदलेगा. अभी आते हैं इन सारी चीजों पे आएंगे. व्हाट इज कोर्स करेक्शन? आई एम फर्स्ट टीचिंग बेसिक्स. समटाइम्स क्या होता है ना, बिकॉज ऑफ सम और द अदर फैक्टर, वो अपना स्पीड थोड़ा कम हो जाए या स्पीड थोड़ा ज्यादा हो जाए, तो उसका हम कोर्स करेक्शन करते हैं. विल कम टू दैट. Sir, gravitational force of Earth will be different at different point at elliptical orbit. Yes, gravitational force is what? Gmm by r square. R changes, so in an elliptical orbit, gravitational force would change. When it is furthest away from Earth, gravitational force would be lowest. When it is very near Earth, gravitational force would be high. Gravitational force is Gmm by r square. Earth revolves on an elliptical orbit. Yes, that's true. Earth revolves on an elliptical orbit. So there are portions on the Earth's orbit where Earth is moving fast. There are portions on the Earth's orbit where Earth is moving slow. That's there. See, Earth का speed of revolution, देखो, Earth का speed of revolution is not same. Let me explain you this. I'm sorry. Let's say this is Sun, and this is Earth moving in a elliptical orbit. तो अर्थ जब यहां से गुजर रहा है तो it is going faster because it is near sun. When Earth is far away from sun, it is moving slowly. You don't realize it क्योंकि आपको तो sun वैसा ही दिख रहा है ना. But Earth's speed is not same. Earth's speed of revolution is not same. It completes one round in 365 days. One revolution in 365 days. But अलग-अलग जगह पे Earth का speed of movement around sun is different. If Earth was moving in a circular orbit, तो its speed would have been same. आ रहे हैं सारी चीजों पे आ रहे हैं. What about air drag? Okay, we'll come to all these things. Let's first orbital velocity, circular, elliptical, that you have understood. Now let's go to different types of circular orbits. So we will divide circular orbits into two categories. We'll divide orbits into two categories: circular orbit and elliptical orbit. We'll first talk about circular orbit in details. Okay, circular orbits are divided into three categories. देखो, पहले हम बोल रहे हैं हम ऑर्बिट्स को दो कैटेगरी में डिवाइड करेंगे. एक सर्कुलर जहां पे रेडियस हमेशा सेम रहे, एक एलिप्टिकल. नाउ विल फर्स्ट टॉक अबाउट सर्कुलर. इन सर्कुलर वी हैव लो अर्थ ऑर्बिट, मीडियम अर्थ ऑर्बिट एंड जियोसिंक्रोनस ऑर्बिट. जियोसिंक्रोनस ऑर्बिट के आगे फिर हाई अर्थ ऑर्बिट होता है. विल टॉक अबाउट दैट टू. नाउ फर्स्ट लेट्स अंडरस्टैंड लो अर्थ ऑर्बिट, मीडियम अर्थ ऑर्बिट एंड जियोसिंक्रोनस ऑर्बिट. अर्थ low earth orbit starts from roughly height of 160 kilometers. I'm saying height, not radius. Radius center of earth से होगा, height यहां से होगी. Low earth orbit starts from 160 kilometers. अगर आप एक circular orbit में जा रहे हो 160 kilometers की height पे, या फिर till a height of 2000. इन दोनों के बीच में अगर आपका ऑर्बिट है you are in what is called low Earth orbit. So if your satellite is revolving in this orbit, you are in low Earth orbit. Fine. So you'll ask, sir, what about 160 kilometers से नीचे? देखो 160 kilometers से नीचे when you launch a satellite, no, it will not be launched, because what happens is अर्थ के पास एटमॉस्फेयर है, ये हवाएं हैं, ये सारी चीजें हैं, right? So what happens if you launch a satellite at this height? If you launch a satellite at this height, let me change the color of the pen. If you launch the satellite at this height, even if you launch it with this horizontal speed of under root gm by r, and you would expect कि it should move in a circular orbit, because there is friction of air, friction of atmosphere, उसका horizontal speed slow होता रहेगा, और horizontal speed कम होगा तो क्या होगा? It will fall back on earth. So till a height of 160 kilometers, satellites are not launched. 160 kilometers से 2000 kilometers तक it is low Earth orbit. Okay, इस low Earth orbit में भी अगर आप सैटेलाइट को यहां पे लॉन्च करोगे, it will be faster when compared to when you launch satellite here. When compared to when you launch satellite here, as you move away from Earth, satellite slow down होगा, distance ज्यादा cover करना है, speed, time taken would be much higher. So here you roughly take 90 minutes at the height of 2000 kilometers. If you launch a satellite takes 2 hours. 2 घंटे में एक चक्कर लगा लेगा, इस ऑर्बिट में 2 घंटे में एक चक्कर लगा लेगा. Fine. From 2000 kilometer to a height of 35786 kilometers, or let me put it to a height of 36,000 kilometers. From 2000 kilometer to a height of 36,000 kilometer. 36 नहीं हुआ exactly, 35786 है, but I have वैसे written it as 36,000 kilometer. This orbit at this height will be called medium Earth orbit. तो अगर आपका सैटेलाइट 2000 किलोमीटर से नीचे वाली हाइट पे, if your satellite is revolving at a height lower than 2000 kilometers, between 160 kilometer and 2000 kilometer, it is in what is called low Earth orbit. From 2000 kilometers to 36,000 kilometers, it is in what is called medium Earth orbit. Okay, this particular height, 35786 kilometer, if your satellite is revolving in a circular orbit at this particular height, it is in geosynchronous orbit. Geosynchronous orbit मतलब यहां पे एक सैटेलाइट उतना ही टाइम लेता है जितना टाइम अर्थ लेता है टू कंप्लीट वन रेवोल्यूशन. अर्थ एक वन रोटेशन, अर्थ एक रोटेशन ऑफ कितने टाइम में कंप्लीट करता है? 24 आवर्स एक रोटेशन. रेवोल्यूशन नहीं, आई एम टॉकिंग अबाउट रोटेशन, जो अर्थ घूम रहा है, जिससे दिन रात हो रही है 24 घंटे में. इट इज बेसिकली 23 आवर्स 56 मिनट्स फ्यू सेकेंड्स. तो एट दिस हाइट 35786, satellite will also take 23 hours 56 minutes and few seconds, and thus this height is called geosynchronous. Geo is earth, अर्थ से सिंक में जहां पे आप रह पाए. And beyond this height, we have high Earth orbit. HEO. Okay, do you understand the difference? Low Earth orbit, medium Earth orbit, high Earth orbit. Clarity है इस पे सबको? Low Earth orbit, medium Earth orbit, high. From a height of 160 kilometers to 2000 kilometers, it's low Earth orbit. Now we are talking about circular orbit. तभी हम बोल पाए. Elliptical orbit में तो distance change होगा. We are talking about circular orbits. From 160 kilometers to 2000 kilometers, it is low Earth orbit. From 2000 kilometers to 35786 kilometers, it is medium Earth orbit. At 35786 kilometers, at the 35,786 kilometer के height पे, it is geosynchronous orbit, because At that height, Earth will take 23 hours, 56 minutes and a few seconds, which is the time taken by Earth to complete one revolution. And beyond that, we have high Earth orbit. So our circular orbits could be divided into these four categories. So let's first come to low Earth orbit. शिवम प्रिया इज आस्किंग जीटीओ का कितना हाइट होता है? बेटा आते हैं ना, एक एक करके सब में आएंगे. Will there be a crash course for Prelims 2022? Are you? नया इंडिया का जो क्वेश्चन था सर, व्हाट अबाउट एयर ड्रैग? आई होप नाउ यू हैव अंडरस्टूड इट. At a height less than 160 kilometers, there is an issue of air drag, and that's why you do not launch satellite at that height. Beyond that, air drag नहीं होता है. Okay, so from a height of 160 kilometers to 2000 kilometers, we have low Earth orbit. Object below 160 kilometer will experience very rapid orbital decay and lose altitude, will eventually fall. Now, low Earth orbit में सबसे ज्यादा हमारी सैटेलाइट्स आती है. मोस्ट ऑफ आवर सैटेलाइट्स, वास्ट मेजॉरिटी ऑफ आवर सैटेलाइट्स आर एट लो अर्थ ऑर्बिट. तो अर्थ 160 किलोमीटर्स, 2000 किलोमीटर्स, हमारी ज्यादातर सैटेलाइट्स इस ऑर्बिट में है. मतलब when you will see satellites revolving around Earth, most of the satellites are in this orbit, right? Most of the human space flight, humans who have gone to space, have also been in this orbit. Other than the human space flight which took humans to moons. Humans moons पे भी गए. Moon का क्या distance है Earth से? 3.5 lakh kilometers से. तो अदर देन व्हेन पीपल वेंट टू मून, व्हेन ह्यूमंस वेंट टू मून, ह्यूमंस जो जाते हैं, जैसे इंटरनेशनल स्पेस स्टेशन इज इन लो अर्थ ऑर्बिट. ओके, तो मोस्ट ऑफ द मूवमेंट, मोस्ट ऑफ द ह्यूमंस हैव आल्सो गॉन टू ओनली लो अर्थ ऑर्बिट. मोस्ट ऑफ आवर सैटेलाइट्स आर इन लो अर्थ ऑर्बिट. नाउ all human space flights have taken to low Earth orbit except the Apollo mission which took humans to moon. All manned space stations and majority of satellites are launched in low Earth orbit. Now, low Earth orbit के कुछ characteristics हैं which now you would be able to understand because you understand the fundamentals of orbits. What are the characteristics? First, it has low orbital period. Low Earth orbit वो जल्दी जल्दी घूमेगा, तो orbital period क्या है? एक चक्कर कितने टाइम में लग रहा है? Orbital period would be very high or very low. एक चक्कर कम टाइम में लग जाएगा, तो in less than 2 hours satellite will be able to complete one revolution around Earth. This is one characteristic of low Earth orbit. Second, user and satellite are closer. Low Earth orbit में आप Earth के पास में हो. When you are in high Earth orbit, you are much away from Earth. Low Earth orbit में you are very near Earth. So those satellites which are supposed to do remote sensing, those satellites which are supposed to do Earth observation, अर्थ को ऑब्जर्व करना, पिक्चर्स बनाना, मैप्स बनाना, सैटेलाइट से आपने कई बार, यू मस्ट हैव सीन गूगल इमेजेस ऑफ योर एरिया. दोस इमेजेस हैव बीन क्रिएटेड यूजिंग सैटेलाइट्स. दोस सैटेलाइट्स वुड जनरली बी पुट इन लो अर्थ ऑर्बिट. अर्थ ऑब्जर्वेशन सैटेलाइट वुड बी पुट इन लो अर्थ ऑर्बिट. व्हाई? आप जितना पास में रहोगे उतना अच्छा रहेगा. इफ यू विल टेक अ पिक्चर फ्रॉम 36,000 किलोमीटर्स अवे, or you will take a picture from 500 kilometer away, which will give you a better resolution. 500 kilometer वाला, 500 kilometer जितने पास से ले पाओगे उतना अच्छा. तो most of the earth observation satellites would go in low earth orbit because user and satellites are closer, so better visibility of earth from satellites. Earth observation or remote sensing satellites go in low earth orbit. तो कॉमन सेंस लगाना. आपको जैसे ही नाम दिखे ना सैटेलाइट का, अब पूछे कौन से ऑर्बिट में जा रहा है, अब देखना नाम है कार्टोसैट. कार्टो मींस मैप. अच्छा, दिस सैटेलाइट इज यूज्ड फॉर मैप मेकिंग. इट मस्ट गो इन लो अर्थ ऑर्बिट. That's how it will be able to take better picture. नाम है resource sat. Let's say the name of the satellite is resource sat. Resources को ढूंढने के लिए वो सैटेलाइट बना है. Where would it go? Low Earth orbit. Common sense. Name of the satellite is Amazonia. अच्छा, अमेजोन रेन फॉरेस्ट को स्टडी करने के लिए बना होगा शायद, मतलब अर्थ को ऑब्जर्व करने के लिए बना है. Where would it go? Low Earth orbit. So most of the Earth observation satellites, most, I'm not saying all, most of the Earth observation satellites would go in what is called low Earth orbit because they are near Earth. Further, low Earth orbit में radiations that our satellite face is also much lower. देखो, most of the radiations that we get them from solar flares. तो अगर आप अर्थ के पास में हो तो सोलर फ्लेयर्स कम आएंगे. अर्थ से जितना दूर जाओगे, सन के पास जाओगे, आपको सोलर फ्लेयर्स ज्यादा मिलेंगे. तो वन अनदर कैरेक्टरिस्टिक ऑफ लो अर्थ ऑर्बिट इज रेडिएशन लेवल्स आर लोअर देन व्हाट इज फाउंड एट हायर एल्टीट्यूड. द रेडिएशंस व्हिच ड्यू टू सन वी फेस आर मच लोअर देन व्हाट इज फाउंड एट हायर अर्थ ऑर्बिट. एंड फाइनली, प्लेसमेंट ऑफ सैटेलाइट इज इजी. देखो, एक सैटेलाइट को आप अर्थ से 500 किलोमीटर की हाइट पे लेके जाओ, एक सैटेलाइट को आपको अर्थ से 36,000 किलोमीटर की हाइट पे लेके जाना है. व्हाट वुड बी इजियर? जो पास में लेके, अर्थ से 500 किलोमीटर दूर जाना आसान रहेगा या 36,000 किलोमीटर दूर जाना आसान रहेगा? 500 किलोमीटर दूर जाना, छोटा रॉकेट भी काम कर जाएगा, कम फ्यूल भी काम कर जाएंगे, राइट? तो इजी प्लेसमेंट. In low Earth orbit, you can easily place satellites, and thus energy spent in placing the satellite is much lower. These are some of the characteristics, some of the features of low Earth orbit. Fine. ये चारों characteristics आपको अच्छे से समझ में आने चाहिए. Now go to medium Earth orbit. अच्छा, before going there, what are the applications of low Earth orbit? Low Earth orbit में आप क्या क्या कर सकते हो? तो Earth monitoring satellites that you understand, as close you are to Earth, it would be better. International Space Station is at a height of 400 km. What is International Space Station? International Space Station को ना ऐसे assume करो, एक सैटेलाइट है बड़ा जिसमें ह्यूमन बींग्स भी रह रहे हैं. एक सैटेलाइट is revolving around Earth and human beings are living inside it. They have created facility कि ऑक्सीजन अवेलेबल रहेगा, टेम्परेचर मेंटेन रहेगा, खाना रहेगा. They are revolving around Earth, but they're there. But some communication satellites are also placed in low Earth orbit. Now you'll ask me, which communication satellites would be placed in low Earth orbit? देखो, think of armed forces. Do our armed forces use mobile phone communication? नहीं. They generally use satellite communication. तो our armed forces, if you have watched movies like, आपने बॉर्डर मूवी देखी हो, कोई भी मिलिट्री वाली मूवीज देखी होंगी, उसमें they have a device, alpha to Charlie, something like they'll say, and the person who's carrying this device will also be carrying a big box behind him. This box is directly communicating with the satellite. Now this box has to communicate with the satellite. Satellite जितना पास रहेगा उतना easy रहेगा. तो for mobile communication जो satellites use होती हैं, they are also put close to Earth. Not all communication satellites go in low Earth orbit, but those satellites which are used for satellite phones, those are communication satellites, they are used for communication purpose, they go in low Earth orbit. These satellites go in low Earth orbit. Fine. What would happen in low Earth orbit? Most of the Earth observation satellites would go in low Earth orbit. International Space Station will go are in low Earth orbit. Then what is in low Earth orbit? Some communication satellites which are used for this purpose also are in low Earth orbit. ये मेरी वीडियोग्राफी टीम ने आज बहुत सारे इनोवेशन कर दिए हैं. अभी मेरा नाम डिस्प्ले हो रहा था. चलिए, low Earth orbit is understood. So any orbit at a height from a height of 160 km to 2000 km would be low Earth orbit. Now low Earth orbit में ना एक particular type है sun synchronous polar orbit. most of our Earth observation satellites go in sun-synchronous polar orbit. Let me briefly help you understand what is sun-synchronous polar orbit. Okay, let me first take these doubts. Sir, what is remote sensing? Remote sensing, दूर से sense करना, दूर से देखना. Remote sensing is basically Earth observation. दूर से देख रहे हो, remote, दूर, sense, observe कर पाना. Why all planets revolve only in elliptical orbit around sun? Interesting question. Why all circular orbit में क्यों नहीं है? देखो, अब समझो. सर्कुलर ऑर्बिट में जाने के लिए द अर्थ, जब अर्थ बना, उसका स्पीड शुड हैव बीन एग्जैक्टली √gm/r. बट स्पीड तो कुछ भी हो सकता है था ना उस टाइम जब अर्थ बना था. तो स्पीड वाज लेस देन √gm/r, इट वुड हैव फॉलन इनटू सन ओनली. वो प्लैनेट एग्जिस्ट करता नहीं. इफ स्पीड वाज मोर देन √gm/r, more than √gm/r, you can understand there are higher chances that speed gm/r रहे या more than √gm/r रहे. √gm/r is a one specific speed. Even slightly more than √gm/r will make it go in ellipse. Much more than √gm/r will make it go in an ellipse. तो नेचर में परफेक्ट √gm/r अचीव करना तो चैलेंजिंग है ना. What would be the probability? Probability would be very less. So most of the planets will revolve around sun in an elliptical orbit. Because any speed, if they are at any speed above √gm/r, they'll go in an ellipse. Because I hope I have answered your question. Do we experience any impact on Earth when its revolving speed changes? No, we do not experience any impact on Earth when revolving speed changes. Surbhi Gupta, it's not always radius increasing, but it's changing. That's why velocity changing. Acha. If satellite in geo take less time, like 4 minutes every 4 minutes, nahi bhai, 90 minutes or so, how are they able to maintain being the same position with respect to Earth? देखो, low Earth orbit wali satellites do not maintain same position on Earth. Geostationary orbit में they will maintain the same position. We'll come to that. अभी हम low Earth orbit पढ़ रहे हैं. Sir, should we make short notes out of notes you have provided? No, you should not. Do not waste your time in making short notes and all. Just go through these notes. Okay, हमें अपने मेंस के लिए short notes बनाने होते हैं. वो 5 points याद रखने. Prelims में flip through these notes only. Why will you repeat the same thing again? Now, come to low Earth orbit is understood by everyone. Lower, from a height of 160 km to 2000 km, orbit is low Earth orbit. Okay, now in low Earth orbit, there is a orbit called polar orbit. ये अर्थ है अपना, ये उसका नॉर्थ पोल है, ये इसका साउथ पोल है. You know, नॉर्थ पोल एंड साउथ पोल ना, ये why, how do we decide कि this is the lower side of Earth? यूनिवर्स में तो कोई लोअर एंड अपर साइड है नहीं ना. Look at the universe. There's no side which is lower side, there's no side which is upper side. If people who are living in southern hemisphere would have done all the research, would have initiated map making, they would have called that as, they would have drawn the image of Earth in the other direction. जो अभी हम साउथ साइड में दिखाते हैं उसे नॉर्थ में दिखाते हैं. चलिए, एनीवेज अभी इस पे डिस्कशन पे नहीं जाते. लेट्स कम टू दिस. दिस इज नॉर्थ पोल, दिस इज साउथ पोल. नाउ पोलर ऑर्बिट्स आर दोज ऑर्बिट्स जहां पे सैटेलाइट्स पोल टू पोल मूव करती हैं. रफली, नॉट एग्जैक्टली, बट रफली फ्रॉम पोल टू पोल. These orbits are called polar orbits. देखो, satellite could move in this direction. This is not polar orbit. This is not moving from pole to pole. This is moving roughly in east-west direction. When satellites are moving from pole to pole, those are called polar orbit. Roughly from pole to pole, not exactly at 90 degree, but 89 degree, 87 degree, 92 degree, 95 degree, 98 degree, 100 degree, 100 degree. Those would be pole to pole or polar orbit. Now, what is sun-synchronous polar orbit? Let's understand this. What is sun-synchronous polar orbit? To understand sun-synchronous polar orbit, देखो, Earth मैं दोबारा अर्थ पर आ रहा हूं, मैं एक बार फिर से अर्थ पर आ रहा हूं. लेट्स से दिस इज इंडिया. Let's say this is India. We are in northern hemisphere, right? This is Africa. अफ्रीका साउथ में भी जाता है, इक्वेटर अफ्रीका से पास हो रहा है, अफ्रीका साउथ से भी जा रहा है, नॉर्थ से, नॉर्दर्न हेमिस्फीयर में भी है. लेट्स से देयर इज अ अर्थ ऑब्जर्वेशन सैटेलाइट, देयर इज अ पोलर ऑर्बिट. हमारा सैटेलाइट इज इन अ पोलर ऑर्बिट. इट्स गोइंग लाइक दिस फ्रॉम पोल टू पोल. आफ्टर सम टाइम अर्थ वुड हैव रोटेटेड. अर्थ इज रोटेटिंग, right? So next time when it comes, it is passing through Africa. Rotate हो गया ना अर्थ. Next time when it's come, it's passing through Africa. Next time when it comes, India आगे हो गया है, अफ्रीका भी आगे हो गया है. It's passing through this part. Because Earth is rotating, the orbit, the satellite which is orbiting Earth will keep coming on this side. This is polar orbit, pole to pole, but it would be considered sun synchronous if whenever it is crossing equator, sun is at the same position. Let's say when it crossed equator here, जब वो इंडिया से गुजर रहा था, तो sun was overhead. Then next time when it is crossing equator, sun should be overhead here. Next time when it is crossing equator, sun should be overhead here. So it is in sync with sun. It is in sync with sun. Did you understand this? Nahi. Let me give you an example. Let's say this is Earth and this is my satellite. And this camera is the sun. This camera is the sun. So this satellite is going like this. After some time, Earth would have revolved a bit. The satellite would now again go like this. It has revolved a bit. Satellite would again go like this. Earth के एक revolution में कई बार ये satellite घूम चुका होगा. It will go like this. Earth satellite would again go like this. Again go like this. But this satellite is always in sync with sun. Sun से वो उसी position पे है. चाहे अगर यहाँ पे when it was passing from the equator and sun was overhead, after some time it will pass from this point, but sun should again be overhead. Sun should again be overhead. Sun should again be overhead. Okay, so let me take you to the. अच्छा यहाँ पे तो image बना ही रखा है ना. Why was I doing so much of effort? See, this is a pole to pole orbit. It passed through this point. Next time when it's passing through this point, agar when it was passing through this point, sun was overhead here. When it is passing again through this point in the equator, sun should be overhead. When it is passing, थोड़ी देर में अर्थ और घूम जाएगा अफ्रीका. It should again be, sun should again be overhead here. It is crossing Africa. Next time it's coming back, sun should again be overhead here. Overhead is just an example. It may be midnight, sun दूसरी side हो. It may be 6, like when it is passing through Earth here and it's 6 a.m. in the morning, sun is just rising. Then when it's passing here, sun should again be just rising. Then when it is passing through here, sun should again be just rising. It should always be in sync with sun. This is sun synchronous orbit. This sun synchronous orbit. It's also called sun synchronous polar orbit. Pole to pole है. Did we all understand what is sun synchronous polar orbit? Now understand an interesting thing. अब देखो, अर्थ तो ऐसे स्ट्रेट नहीं है. अर्थ इज इंक्लाइंड एट 60 डिग्री सेल्सियस, 66 डिग्री सेल्सियस टुवर्ड्स सन. ऐसा सीन है. अर्थ मूव्स इन इंक्लाइंड ऑर्बिट. नाउ लेट्स से मैं सन हूं, ये अर्थ है, और अर्थ इज राइट नाउ इंक्लाइंड इन दिस डायरेक्शन and this orbit is like this. So it is always facing sun. Let's say this is the scenario. Fine. What happens in 3 months? In 3 months, which period of the year am I talking about here? I'm talking about March. Why? March May, northern hemisphere is inclined towards sun. March May, northern hemisphere is inclined toward March. नहीं, I'm talking about June. This is June. June में northern hemisphere is inclined towards sun. June में हमारे यहाँ गर्मी होती है north में, because we are inclined towards sun. But by September, अर्थ का इंक्लिनेशन तो यही रहता है ना. बाय सितंबर आप देखेंगे सितंबर में ऐसा नहीं है कि नॉर्दर्न हेमिस्फीयर इज इंक्लाइंड टुवर्ड्स सन और सदर्न हेमिस्फीयर इज इंक्लाइंड टुवर्ड्स सन. सन इधर है, इसका इंक्लिनेशन उस तरफ है. तो आप देखेंगे सितंबर में ना ज्यादा गर्मी होती है ना ज्यादा सर्दी होती है. सन इज ऑन द इक्वेटर डायरेक्टली. नाउ कम टू दिस पॉइंट अगेन. इफ दिस ऑर्बिट वाज लाइक दिस and if this orbit remains like this, will it be in sync with sun? Let me draw a figure and then explain you. I'm sorry. Sun and ये अर्थ का ऑर्बिट. Let's say this is earth. Earth is inclined at an angle of 66 degree. तो ये हमारा जून 22 का डेट है, where sun is directly on Tropic of Cancer, not on equator. Sun is falling on Tropic of Cancer. And let's say मेरा orbit is in this direction. My polar orbit is this. तो अर्थ थोड़ा थोड़ा रोटेट हो रहा है. Polar orbit next time is also in front of sun, next time is also in front of sun, next time is also in front of sun. It is in sync with sun. But when earth reaches here, earth was here, earth reaches here, this is September. If the polar orbit was like this, जैसे यहां पे था, will it remain in sync with sun? No. Sun is facing this side. Polar orbit should have been on this side. It should be coming out. Sun synchronous polar orbit should have been coming out. तभी it will be in front of sun, no? You getting my point? मुझे इन बच्चों को समझ में आ रहा है कि Are you able to understand this? पक्का? एक मेरे को फिर से समझाने दीजिए. This is Earth. कैमरा सन. और नहीं, कैमरा सन नहीं, मेरे को सन बनाते हैं क्योंकि रोटेट कर पाएगा ना इसके अराउंड. मैं सन हूं, ये अर्थ है. अभी दिस इज द पोलर ऑर्बिट. ओके, एंड लेट्स से दिस इज पॉइंटिंग इंक्लिनेशन. तो अभी इंक्लिनेशन इज इन दिस डायरेक्शन. आफ्टर सम टाइम अर्थ वुड बी हियर, अर्थ वुड बी हियर. इंक्लिनेशन इज व्हाट? इन दैट डायरेक्शन नाउ. If it keeps revolving, if the orbit keeps revolving here, is it in front of sun? No. This is this, so it does not remain in sync with sun. So to remain in sync with sun, this orbit will also have to revolve, rotate. यहाँ पे ये ऑर्बिट ऐसा था, यहाँ पे इस ऑर्बिट को ऐसा होना पड़ेगा, यहाँ पे इस ऑर्बिट को ऐसा होना पड़ेगा, यहाँ पे इस ऑर्बिट को, this orbit will also have to rotate. Okay, have you seen लट्टू? लट्टू देखा है? लट्टू घूमता है, लट्टू घूमता है, रोटेट होता है, बट लट्टू ऐसे रिवॉल्व भी होता है. तो दिस ऑर्बिट ऑल्सो, इट इज लाइक दिस, बट इट शुड ऑल्सो कीप रिवॉल्विंग. इट कैनॉट रिमेन लाइक दिस. इफ इट रिमेन्स लाइक दिस, जब अर्थ यहां पे आ जाएगा, मैं सन हूं, जब अर्थ यहां पे आ जाएगा, इट वुड बी गोइंग लाइक दिस. इट विल नॉट रिमेन इन सिंक विथ सन. So this orbit, which is in this direction now, will have to become this direction by the time it comes here, in sync with sun, in sync with sun, in sync with sun. Sun synchronous polar orbit. So sun synchronous polar orbit roughly in 365 days have also to revolve 360 degrees Celsius. Every day 1 degree से move होना पड़ेगा, 1 डिग्री इसे घूमना पड़ेगा. Sun synchronous orbit will have to 1 degree almost every day. एक तो this is the orbit, but this orbit will also have to rotate. Fine. सबको समझ में आ रहा है पक्का? Guys, sun synchronous orbit, it would be a polar orbit ना, pole to pole तो है ही ना भाई. Pole to pole तो है, तो it will remain polar orbit. Okay, tomorrow I'll get a globe. मैं उस पे समझाने की कोशिश करूंगा फिर से. Okay, और do I have any circular part? Let me again. ये हमारा अर्थ है, ये इंक्लिनेशन है, यहाँ पे अर्थ का इंक्लिनेशन ऐसा हो गया है in 3 months, right? यहाँ पे अर्थ का इंक्लिनेशन दूर. This is the inclination of Earth. This is how things go, right? Now let me come back here. If this is my pole to pole orbit, so I'm facing sun. This orbit is facing sun always. अगर अर्थ जब यहां पहुंचता है, this is June, this is September, and if it keeps revolving like this, is it facing sun? Is this orbit facing sun? No. This orbit will also have to become this. So basically, this orbit, which was like this here, will have to become like this here. Will have to become like this here. Always being in sync with sun. Sun synchronous polar orbit. Did you understand what is sun synchronous polar orbit? This sun synchronous polar orbit, not only a satellite does not only revolve around Earth, but this orbit also keeps shifting by 1 degree every day. Almost 365 days में 360 degree इसे घूमना पड़ेगा. This is sun synchronous polar orbit. It precesses once a year. जो revolve करने की बात करें जैसे लट्टू, other than rotating, it also precesses. It precesses once a year, and typical sun synchronous orbit is achieved at a height of 600 to 800 kilometers. So 160 kilometer to 2000 kilometer is what? Low Earth orbit. So sun synchronous polar orbit is a low Earth orbit. Inclination of around 98 degrees Celsius. 98, roughly 90 degree would have been pole to pole. Roughly pole to pole. So sun synchronous polar orbit. Now there's an interesting thing. Sun synchronous polar orbit is only possible around oblate planets. What are oblate planets? Oblate planets ना, obesity वाले planets, जिनके पेट के पास ज्यादा मास है. जैसे अर्थ has much more mass near equator. Earth is not a perfect sphere. Earth is a geoid. जहां पे पोल्स के पास वो थोड़ा प्रेस्ड है एंड इक्वेटर के पास मास ज्यादा है. तो sun synchronous polar orbits are only possible around Earth-like planets, oblate planets like Earth and Mars. Venus is a spherical planet. Venus more or less spherical है. Venus मतलब शुक्र, Mercury, Venus, Earth, Mars ना. तो वहां पे ये possible नहीं होता. It is only possible around planets like Earth and Mars. Now, what is the significance of sun synchronous orbit? Why are we complicating things so much, and why are we making this sun synchronous orbit? Why do we want to launch satellite in sun synchronous orbit? Let's say we are launching a satellite to observe the forest cover. But if this satellite was taking one image at 5 a.m. in the morning, other image at 7 a.m., other at 9, other at 11, other at 12, other at 1, then comparing these images would not have been feasible. If all these images have come at the same time, रोज 11 बजे का हम इमेज ले रहे हैं और 5 साल के इमेजेस को कंपेयर करेंगे, तो we'll be able to better observe what changes have taken place. But if these images are in different sunlight, then comparability of the images would not be good. This is the core purpose. आप जो भी इमेज ले रहे हो, सनलाइट उतनी ही होनी चाहिए उस टाइम. In sun synchronous, because it's always in sync with sun, so sunlight more or less remains same. So all the images are taken of a point of our Earth at the same sunlight, so that comparability of different images over the period of, let's say, 5 years, will help you understand, okay, here green cover is reduced. This darkness has reduced not because of change in sunlight, but because of change in green cover. So Earth observation satellites are generally put in low Earth orbit because low Earth orbit पास में होगा, are generally put in sun synchronous polar orbit. अर्थ ऑब्जर्वेशन सैटेलाइट लो अर्थ ऑर्बिट में जाता है, बट लो अर्थ ऑर्बिट में भी कौन से पार्ट में प्रेफर करते हैं हम? सन सिंक्रोनस पोलर ऑर्बिट में, बिकॉज सन सिंक्रोनस पोलर ऑर्बिट विल गिव यू क्लियर पिक्चर, कंपेरेबल पिक्चर्स. सन इन ऑलवेज सेम काइंड ऑफ लाइट. फाइन. सन सिंक्रोनस पोलर ऑर्बिट इज अंडरस्टूड बाय ऑल ऑफ यू. नाउ विल गो टू मीडियम अर्थ ऑर्बिट. अच्छा, बिफोर मीडियम अर्थ ऑर्बिट लेट्स टेक द डाउट्स. So sun synchronous will give clear picture of the whole earth. देखो गिरधर, please understand, sun synchronous doesn't mean that always sunlight. Sun synchronous can also mean always midnight. Sun synchronous may also mean always 6 a.m. or always whenever it's crossing the equator at 6 a.m. So next time when it will cross the equator 6 a.m., 6 a.m., 6 a.m., 6 a.m. So it will give pictures which are at the same sunlight. What sir is saying is that the satellite adjusts the orientation of orbit 1 degree every day to maintain being in sync with sun. Yes, 1 degree. This orbit will have to rotate by 1 degree every day. मतलब 365 days में 360 degrees, तो 1 degree से थोड़ा सा कम. Yes, yes, Akshay. Vedita is asking, sir, it means with satellite orbit will also rotate and revolve with earth in order to be in sync with sun. Yes, yes, Vedita. Fine. Sun synchronous orbit is understood by all of you. Low earth orbit का यही एक टाइप था, sun synchronous orbit. Now let's go to medium earth orbit. So from a height of 2000 kilometers to a height of 35786 kilometers, it is medium earth orbit. Medium earth orbit में, in a circular medium earth orbit, the time taken by satellite is from 2 hours 2000 kilometers पे. एक अर्थ का एक चक्कर लगाने में कितना टाइम लगेगा? 2 घंटे लगेंगे एक सैटेलाइट को. फ्रॉम 2 hours to 24 hours एट अ हाइट ऑफ 35786 किलोमीटर. कितना टाइम लगता है? Geosynchronous at a height of 35786 kilometer we come to geosynchronous orbit. How much time does it take? 23 hours 56 minutes and a few seconds, roughly 24 hours. So medium earth orbit will be at a height from 2000 kilometer to 35786 kilometer. Satellite speed is lower. Speed of the satellite would be lower when compared to low earth orbit. आप अर्थ के जितना पास रहोगे, लो अर्थ ऑर्बिट में आप पास थे, अब दूर जा रहे हो, स्पीड ऑफ सैटेलाइट वुड बी लोअर. Orbital period 2 hours to 24 hours depending on where you are. At a height of 2000 kilometer your orbital period will be 2 hours, 2100 kilometer, 2200 kilometer, 2300 kilometer, 3000 kilometers, 30,000 kilometers, 35,000 kilometers. Your orbital speed will keep decreasing. This satellite is mostly used for navigation and communication purposes. तो आज हम पढ़ेंगे GPS. GPS, all of us use GPS in our phones. अपना GPS लोकेशन भेज दे. तो GPS is a system which has been developed by NASA. They have lots of satellites revolving around Earth. They are all in medium Earth orbit. Medium Earth orbit 2000 किलोमीटर से 36,000 किलोमीटर के बीच में. In between 2000 kilometers to 36,000 kilometers, or all the satellites of GPS are at a special height of 20,200 kilometers. What is so special about 20,200 kilometers? देखो, at 2000 kilometers, how much time will Earth take? Or how much time will the satellite take? 2 hours. At 35,786 kilometers, how much time will the satellite take? 24 hours. At 20,200 kilometers, it is medium Earth orbit में one of the orbits, one of the heights. Here the satellite will take how much time? 12 hours. तो एक दिन में 2 चक्कर लगाएगा सैटेलाइट if it is put in this orbit, and all the GPS satellites are put in this orbit. So GPS is at a height of 20,200 kilometers. Galileo, the sat-nav system of Europe, is also located in medium Earth orbit. Baidu is the satellite navigation system of China. Most of its satellites are also located in this orbit, in medium Earth orbit. India का क्या है? Satellite navigation system, Navik और IRNSS. इंडियन रीजनल नेविगेशन सैटेलाइट सिस्टम और नेविगेशन यूजिंग इंडियन कॉन्स्टलेशन, हम पढ़ेंगे उसके बारे में आज ही. दैट इज एट अ हाइट ऑफ geosynchronous orbit. That's not in medium earth orbit. So most of the navigation system is in medium earth orbit, but India वाला नहीं है, India वाला geosynchronous में है. Okay, now let's talk about geosynchronous orbit. So you understand what is low earth orbit? You understand what is medium earth orbit? Medium earth orbit के characteristics क्या क्या है? And medium earth orbit में कौन से satellites जाते हैं? Generally सैटेलाइट नेविगेशन सिस्टम वाले सैटेलाइट्स मीडियम अर्थ ऑर्बिट में जाते हैं. नाउ लेट्स कम टू जियोसिंक्रोनस ऑर्बिट और जियोस्टेशनरी ऑर्बिट. व्हाट इज जियोसिंक्रोनस ऑर्बिट, व्हाट इज जियोस्टेशनरी ऑर्बिट? देखो, जियोसिंक्रोनस ऑर्बिट इज एन ऑर्बिट वेयर ऑर्बिटल पीरियड इज 23 hours 56 minutes 4 seconds. What is meant by this orbital period? 23 hours 56 minutes 4 seconds. What is meant by this? If this is Earth, this is India. Earth completes one rotation in 23 hours 56 minutes 4 seconds. ये हमारा let's say orbit है. It is also completing one rotation in 23 hours 56 minutes 4 seconds. So after 23 hours 56 minutes 4 seconds, it will be back at the same point. तो जैसे इंडिया से कोई let's say हम यहाँ दिल्ली में बैठे हैं, we are sitting in Delhi here and we look at a satellite. Oh, this satellite is here. After 23 hours 56 minutes 4 seconds, we would come back to this point, but in this time this satellite would have also completed one revolution and would have come back to this point. So after one day we'll see, oh, see that satellite is again there. So what is geosynchronous satellite? Geosynchronous satellite is a satellite which will be back at the same position in 24 hours. It is in sync with Earth. Earth से sync में रहेगा, 24 hours में it will be back at the same position. So to ensure that satellite is revolving, one revolution of satellite is taking place in 23 hours 56 minutes 4 seconds, you have to put it in a circular orbit at a height of 35,786 kilometers. And its direction of rotation should also be the direction of rotation of Earth. अगर Earth ऐसे घूम रहा है तो satellite भी ऐसे घूम रहा हो. अगर satellite दूसरे direction में घूम रहा है, Earth ऐसे घूम रहा है, तो after 12 hours you will see the satellite again. But we are talking about 24 hours वाला system. Okay, so what is the condition for a satellite to be in geosynchronous orbit? Circular orbit of a height of 35,786 kilometers. If this is the situation, satellite is in what is called geosynchronous orbit, and direction of the revolution of satellite should be same as direction of rotation of Earth. Agar satellite is moving in a different direction, Earth is moving in a different direction, then satellite would go here, India would reach here, and in 12 hours only you will be able to see it again, but at a different position. We don't want that. Geosynchronous orbit, you are completing one revolution in 24 hours, Earth is completing one rotation in 24 hours. Let us come back to the same position in 24 hours. This makes you in sync with Earth. This is geosynchronous orbit. Fine. Geosynchronous orbit का clarity है सबको without any problem, without any doubts. Now in geosynchronous orbit, what actually happens is it roughly forms a shape of 8. Let's say this is Earth, Earth, India, Delhi. You're sitting in Delhi. Let's say this is a geosynchronous orbit at a height of 35,786 kilometers. And अभी हम यहाँ पे हैं, तो we have the satellite here in front of us. After some time, where would we reach? We would reach somewhere on this side. This point would reach here, but the satellite would move a bit on top. ये ऊपर जाएगा, फिर सैटेलाइट नीचे आना शुरू करेगा. फिर it will come down, it will go up, but will be at the same height. अर्थ रोटेट हो रहा होगा, will be at the same height. So to us, the satellite would roughly appear to be making an 8. हम देखेंगे सैटेलाइट कैसे मूव हो रहा है. सैटेलाइट ये गया, अब नीचे आ. When satellite is coming down, सैटेलाइट नीचे आ रहा है. Satellite will cross us. Satellite will further go down. दूसरी साइड देखो, दूसरी साइड. We have also gone on the other side. Satellite would go down, then it would start coming up. It would start coming up. It will again go above us. It will again go above us. Will come down. Will further go down. Will start coming up. It will go above us. So geosynchronous satellite roughly forms a shape of 8. Geosynchronous satellite does not appear stationary to us, but in 24 hours it will come back to the same point. In 24 hours it will come back to the same point, but it is not stationary. Geosynchronous satellite is not stationary. It will come back to the same point in 24 hours. Fine? ये बात समझ में आई? But देखो, geosynchronous, in a way, if we launch geosynchronous exactly above us, you would see that it will always be visible to us. It will be forming the shape, but it will always be visible to us. So generally, communication satellites are put in geosynchronous orbit. Why? To communication satellite, you would always want to communicate. It should always be. In case of low Earth orbit, what would happen? Half of the time satellite would go on the other side. 2 घंटे में वो एक चक्कर लगा रहा है, तो 1 घंटे बाद तो दूसरी साइड चला जाएगा ना अर्थ के. आपको तो दिखेगा ही नहीं, आप उससे कम्युनिकेट कर ही नहीं पाओगे. You will not be able to communicate with it. Geosynchronous में you will not be able to, in low Earth orbit, you will not be able to communicate with the satellite all the time. Half of the time it will be on the other side. But in geosynchronous, what is happening? Satellite is always visible to you. It's sometimes going up, it's going down, but it's always visible to you. On the other side, the satellite would never be visible. If you'll go to USA, उनके लिए ये सैटेलाइट हमेशा पीछे रह रहा है, अर्थ के उस तरफ है. It is revolving, Earth is also rotating. It roughly forms this shape. So what are the 2 conditions for geosynchronous orbit? It should be circular orbit. It should be at a height of 35,786 km. Plus एक और condition. What condition? It should be moving in the same direction as the direction of Earth's rotation. Earth is rotating in this direction. Satellite is also rotating in this direction. Only then we are able to see this shape of 8. Fine. अब एक interesting चीज करते हैं. What if the satellite is still geosynchronous? India, satellite is geosynchronous, but it is over the equator. Circular orbit at a height of 35,786 km above equator. अगर हम सैटेलाइट को इक्वेटर के ऊपर डाल देते हैं, at a height of 35,786 kilometers. In this situation, what happens? In this situation, what happens? Satellite, is it geosynchronous? Yes, it is geosynchronous. At a height of 35,786 kilometers, circular orbit, rotating in the same direction as the direction of Earth, so it is geosynchronous. In 24 hours, it will come back to the same point. But it's also stationary. In 24 hours, it comes back to the same point, but it remains on the same point always. यहाँ पे जो ये 8 शेप बन रहा था ना, वो 8 शेप नहीं बनेगा. यहाँ पे शेप क्या बनेगा? Satellite is always stationary. So, if geosynchronous satellite को you bring in, rather than at an inclination, you bring it exactly above equator, you would to you it would appear that satellite is always stationary. For example, let me visualize you this thing. Equator थोड़ा श्रीलंका के नीचे से पास हो रहा है, श्रीलंका के वहां से पास हो रहा है, right? Let us, we are sitting in India here, we are sitting in Delhi. Southern hemisphere में इक्वेटर है, हमारे साउथ में इक्वेटर है. लेट्स से इक्वेटर के जस्ट ऊपर हमने एक सैटेलाइट को लॉन्च कर दिया at a height of 35,786 kilometers. So it will take 23 hours 56 minutes 4 seconds to complete one revolution. Now we see the satellite there right now. After some time, we would have also moved a bit. The satellite would have also moved a bit. Satellite would again appear there only. It will always appear there. It will always appear stationary. In case of geosynchronous, what was happening? It was coming thoda upar, then going down, then going further down, then coming up. It was forming 8. But geosynchronous का एक special type जहां पे satellite would always appear stationary. Imagine this. कि there's a large circle above equator जिसमें एक satellite is taking exactly 24 hours to complete one revolution, exactly 23 hours 56 minutes 4 seconds to complete one revolution. Imagine that circle and socho कि because it's also taking 24 hours, you are also taking 24 hours, you'll always be seeing the satellite at the same point. It will appear stationary. और मान लो सैटेलाइट को आपने यहां लॉन्च नहीं किया, वहां पे लॉन्च किया था अफ्रीका के ऊपर. Even then, always it will appear there. After 4 hours, you would have moved a bit. The satellite would have also moved a bit. It would appear there to you. So geostationary is a special type of geosynchronous satellite. Geosynchronous to hai ye. It is completing one revolution in 24 hours. It is geosynchronous. Geostationary is a special type of geosynchronous where what's happening? The satellite is appearing stationary. What was the condition of geosynchronous? After 24 hours, you should be appearing to me at the same place. यहाँ पे after 24 hours, is it appearing at the same place? Yes. But it is always at the same place. So one of the special type of geosynchronous orbits is geostationary orbits. In geosynchronous, you are moving on an inclination. In geostationary, you move over the equator. What is one big advantage of geostationary satellite? When you have to do communication, आपने अपने एंटीना का डायरेक्शन एक जगह डाल के छोड़ दिया. Because satellite is always there, your antenna, your receiver will always be able to get data from there. So most of the communication satellites go in a geostationary orbit because you always want to communicate with it. How would you make a geostationary orbit? Sare condition of geosynchronous plus the satellite should be above the equator. It makes it geostationary. Okay. Let me take these doubts. Pravesh Sony is asking, then sir, angle of satellite on the earth is also changing with revolution of earth. Huh. In geosynchronous, yes. How sun synchronous satellite presses. This extra mass on the surface of or near equator helps sun synchronous in precessing. What speed is more so it makes elliptical, but why is it makes only one side elliptical and not elliptical on all around because of its speed is नहीं it's elliptical all around. Ellipse is not कि एक side elliptical होता है दूसरा side circular होता है. It's elliptical all around भाई. I'm sorry I'm not very good at drawing figures, so it may appear कि एक side circular बनाओ. It's elliptical all around. Why 35786 kilometer? बेटा देखो, as you are moving away from Earth, your orbital time period is increasing now. So there would be one height where orbital time period would be, where orbit period would be 24 hours. So this in this case has come out to be 35786. If the time taken for satellite in geosynchronous to complete revolution is 23 hours 56 minutes, this is roughly 4 minutes less every day. How are they able to maintain the same position every day? Bhai, CBSG, Earth also takes 23 hours 56 minutes 4 seconds. Earth does not take 24 hours. Earth takes 23 hours 56 minutes 4 seconds. तभी ये 4 मिनट हर रोज कम होते रहते हैं ना. तो this 4 minutes in 4 years make 1 day. And that's why आपको लीप ईयर आता है जहां पे February will be 1 day. It is because of this 4 minutes. So Earth takes 23 hours 56 minutes 4 seconds. पीयूष इज आस्किंग सर व्हाई डिड वी रिस्ट्रिक्ट आवरसेल्व्स टू रीजनल। अरे अभी आते हैं ना, आईआरएनएस से भी पढ़ा नहीं, उससे पढ़ेंगे तो उसके बारे में बात करेंगे। सर हाउ 8 विल बी फॉर्म, प्लीज एक्सप्लेन इट। बेटा एक बार ना खुद से सोचना, मतलब ड्रॉ अ सैटेलाइट का पाथ and think of yourself, you are moving in a circle, satellite is moving in a circle but which is at an inclination. You will see the formation of this 8 for you. Yes, ये किसी ने अपना उर्दू में या किसी दूसरे लैंग्वेज में नाम लिखा है जो मैं समझ नहीं पा रहा, but the student is asking geostationary orbit is part of geosynchronous plus it should be above equator. Yes, geostationary is a type of geosynchronous because it is satisfying all the conditions of geosynchronous, plus it should be above the equator. You're right. CMU is asking, sir, so many countries cannot launch geosync plus equator satellite, otherwise there will be too many satellites for the same purpose on the same path. No, CMU, it doesn't work like this. Just imagine 36,000 kilometers above Earth. Earth का रेडियस कितना है? 6400 किलोमीटर है। फिर भी कितना बड़ा इक्वेटर है सोचो। अब 36,000 किलोमीटर अबव अर्थ, कितना बड़ा रेडियस होगा? 36,000 इंटू 2 पाई आर, पाई इज 3.14, 3 मान लेते हैं, 2 is 2, 6, 36,000 इंटू 6, लगभग 2 लाख किलोमीटर का रेंज है। 2 लाख किलोमीटर में जितने मर्जी उतने सैटेलाइट डालो ना, एंड द बेस्ट पार्ट इज उन सैटेलाइट्स की स्पीड नहीं बदल रही, दे विल नॉट कोलाइड, they're all moving at the same speed, right? Why do we face accidents? Someone is moving fast, someone is moving slow, ठोक देते हैं. Here satellite have very long road and they're all moving at the same speed. Okay, I hope CMU I have answered your question. Now advantages देख लेते हैं geosynchronous geostationary के. They have much larger available of bandwidth than the low Earth orbit or medium Earth orbit satellites. They cover 1/3 of the Earth's surface. They, like, see what happens is Earth एक सैटेलाइट जो इतनी दूर है लो अर्थ ऑर्बिट में, एक सैटेलाइट जो इतनी दूर है जियोसिंक्रोनस ऑर्बिट में. This satellite would be able to cover only a small portion of Earth, but this satellite would be able to view a large portion of Earth. Right? Did you understand? Do you understand this? आप जितना दूर जाओगे उतने बड़े एरिया को देख पाते हो ना अच्छे से. Less expense on tracking activities. Why? यहाँ ट्रैकिंग की ज्यादा टेंशन नहीं, एक ही जगह पे. तो ट्रैकिंग एक्टिविटीज पे लेस एक्सपेंस वुड बी देयर. हायर लाइफ स्पैन ऑफ द सैटेलाइट. एज यू मूव अवे फ्रॉम अर्थ, तो अर्थ का जितना भी वो एयर और उसकी वजह से फ्रिक्शन होता है वो कम होता जाएगा. तो the further away the satellite is, the higher its life would be. But there are some limitations. It would require line of sight communication path between terrestrial antenna and satellites. Long path length, like अर्थ से जब आप सैटेलाइट पे कम्युनिकेट कर रहे हो, the distance that this electromagnetic wave your signal has to travel is much higher. So in this high distance the loss may be higher, the noise that it may face may be higher. Then satellite costlier to install. Why? Because you have to take satellite to such a high. Low Earth orbit mein you could take satellite easily, but geostationary mein you have to take satellite to a much bigger height. Then geostationary orbit can only be above equator and therefore poles can't be covered. This is an interesting thing. Because Earth is not a sphere, Earth is a geoid. Poles के पास क्या है? Earth is, अगर Earth पूरा sphere नहीं है, what is Earth is, rather than being sphere, it is a bit plane. It is a bit plane near the poles. It's a geoid. Now in this scenario what happens, if this is my geostationary orbit, it is not able to cover the polar region. तो जियोस्टेशनरी सैटेलाइट ऑलमोस्ट 120 डिग्रीज कवर कर लेते हैं. आप 3 जियोस्टेशनरी सैटेलाइट लगा दो, एक यहाँ पे, एक यहाँ पे, एक ऑन द अदर साइड, यू विल बी एबल टू कवर द एंटायर अर्थ, बट यू विल नॉट बी एबल टू कवर पोल्स. Geostationary will have to be above equator. It cannot be here, it cannot be here. So geostationary satellites are not able to cover poles. This is one of the limitations. Fine. फिर इसके beyond we have high earth ऑर्बिट. हाई अर्थ ऑर्बिट में सैटेलाइट्स हम डालते नहीं है. तो सर्कुलर ऑर्बिट्स में वी हैड 3 ऑर्बिट्स. लो अर्थ ऑर्बिट, most of the earth observation satellites, some communication satellites may also go there, but most of the earth observation satellite and satellite phone communication, international space station, they are lying in low earth orbit. Then we have medium earth orbit. Medium earth orbit mein we generally have satellite navigation systems like GPS, Baidu, Galileo. Then we have geosynchronous and geostationary. Geostationary is a special type of geosynchronous. Geosynchronous orbit would be that orbit where satellite takes 23 hours, 56 minutes, 4 seconds to complete one revolution. This is done. This is understood. All of you are very clear about it. उसी का एक type है geostationary. Most of our communication satellites go in geostationary or geosynchronous orbit. These were 3 types of circular orbit. I'm assuring you, आपको लगा होगा कि यार ये 2 घंटे चला ये session, but these 2 hours will simplify your life for next 10 hours. Will simplify your life of your space preparation. Abhi we will do very complicated things. We'll talk about Lagrangian points. We'll talk about hundreds of other complicated things. All of those would be simplified because of your understanding of this portion here. Okay, now let's go to highly elliptical orbits. Highly elliptical orbits, jab it will form an ellipse. When it is near Earth, it will be moving fast. When it's away from Earth, it would be moving very slowly. It would be like that. Okay. Transfer orbits की बात करते हैं. What are transfer orbits? I'm sorry. ट्रांसफर ऑर्बिट क्या होता है इसे समझते हैं. अर्थ, लो अर्थ ऑर्बिट, जियो सिंक्रोनस और जियो स्टेशनरी ऑर्बिट. समझ रहे हो? लो अर्थ ऑर्बिट इज ओनली 500 किलोमीटर अवे. जियो सिंक्रोनस जियो स्टेशनरी ऑर्बिट इज वेयर 3,500, 786 kilometers away. 500, 3,500, 35,000 kilometers away. 500 kilometer, 35,000 kilometers. कितना ज्यादा डिफरेंस है, right? तो launching a satellite here is easier. Launching a satellite there would be difficult. Therefore, we do not take our rockets to this point directly. We take the help of what is called transfer orbit. What is transfer orbit? Transfer orbit is an elliptical orbit like this. So देखो, from Earth you take your rocket to low Earth orbit, you launch your satellite. But from Earth taking your orbit to geosynchronous orbit, which is very far away, would be difficult. So rather than doing that, what you do is your rocket will bring the satellite to this point and will launch it at a high speed so that it goes in a elliptical orbit. The rocket will bring the satellite to low Earth orbit wala height pe, and then it will launch it with a high speed so that it goes in a elliptical orbit. Rather than launching it with under root gm by r, it launches it with speed much higher than under root gm by r. यहाँ पे we will need a very powerful rocket. And then when अब rocket का काम खत्म, अब satellite is moving. When the satellite reaches this height, this elliptical orbit का जो apogee होगा, जो furthest most point होगा, it may be more than this height, 35,786 kilometers. So when the satellite reaches this height, satellite is send a signal. Satellite has some engine in it. Generally उसको engine की जरूरत नहीं होती, but still for maneuvering purpose, satellite is given some engine. It is send a information. Change your direction, change your speed. तो सैटेलाइट अपना इंजन थोड़ा सा स्टार्ट करेगा, वो अपना स्पीड और डायरेक्शन वैसा कर लेगा so that it becomes a circular orbit. So this is transfer orbit. This elliptical orbit which is used to transfer satellite from low Earth orbit to geostationary orbit or geosynchronous orbit is transfer orbit. It is called geosynchronous transfer orbit when the transfer takes place in this manner. अब देखो preparation आसान हुई ना? You understood how a satellite is launched in an elliptical orbit. When it is launched at a speed more than under root gm/r, it goes in an elliptical orbit. So how did we launch the satellite in the elliptical orbit? Our rocket brought the satellite here, launched it at a very high speed. It went into an elliptical orbit. When it reached here, we asked satellite, start your engine, change your direction, change your speed, so that your speed here, so that your speed here becomes what? Under root gm/r, where r is this distance. So that now you would, so what you will see whenever communication satellites are launched, these communication satellites are not being launched in geostationary directly. They are launched in what is called GTO, geostationary transfer orbit. And after the satellite is launched in geostationary transfer orbit, satellite will go to that height by using this mechanism. And when it reaches that height, it starts some of its engine and goes in the direction. Did you understand what is geostationary transfer orbit? Let's come back to this. Earth, low Earth orbit, elliptical orbit. Elliptical orbit का जो perigee है, perigee is the furthest most point, apogee is the nearest most point. तो elliptical orbit का जो perigee है, that is further away from Earth. At perigee, it changes its direction and comes into this geostationary orbit. Geostationary transfer orbit का example देखिए. Your rocket brought the satellite till this point, launched it at a very high speed. When it reached this height, it changed its direction and moved to this. So this is a transfer orbit, geostationary transfer orbit. So let's summarize everything that we have done so far before we start solving some questions. जब तक चलेगा चलेगा, जब तक मेरे में जाने चल पढ़ाते रहेंगे. जाना है आपको? Okay, let me summarize everything. Now you may think that ये कुछ complicated सा कुछ आ गया अजीब सा. Do not worry, कोई complication नहीं है. Simply क्या बता रहा है ये देखो. This is telling you the radius of the orbit or height above sea level. This is telling you the height above sea level. तो देखो, at a height of 20,200 kilometers, this blue line is there. Medium Earth orbit, height of 35,786 kilometer. High Earth orbit. तो अब आप देखोगे ज्यादातर कम्युनिकेशन सैटेलाइट यहाँ है, ज्यादातर सैटेलाइट नेविगेशन वाले यहाँ पे है मीडियम अर्थ ऑर्बिट में. एंड दिस इज लो अर्थ ऑर्बिट. लो अर्थ ऑर्बिट में स्पीड इज वेरी हाई, तो यू वुड सी दैट स्पीड ऑफ सैटेलाइट 25,000 किलोमीटर पर आवर. The speed keeps decreasing, 20,000 kilometers per, 15,000 kilometers per hour. As the height is increasing, speed is decreasing. So, International Space Station is at low Earth orbit. Hubble Space Telescope is at low Earth orbit. But you will see that the medium Earth orbit में क्या क्या है? GPS is at medium Earth orbit. Galileo is navigation system of Europe. It is at medium Earth orbit. GLONASS is navigation system of Russia. It is at medium Earth orbit. Then this is geostationary orbit. Did you understand? यहाँ पे मैं क्या बताने की कोशिश कर रहा हूँ? Speed is जो हमने कैलकुलेट किया. Speed is very high near Earth. As you move away from Earth, speed decreases. Distance to be covered increases. The time taken increases. Time taken to complete one revolution. Come here. Medium Earth orbit में 2 घंटे तक में हो जाता है. As you move up 5 hours, 10 hours, 15, 12 hours, 15 hours, 20 hours, 24 hours. Time taken to complete one revolution. मैंने विकिपीडिया से एक ये इमेज लिया था, because I found it like it is summarizing a lot of things. Speed decreases, time to complete one revolution increases, height above sea level in kilometers, radius. देखो, all the distances that we talked about, 160 kilometers above Earth, वो height था. उसका radius क्या होगा? 160 plus radius of Earth. हमें रेडियस तो सेंटर ऑफ अर्थ से कैलकुलेट करना पड़ेगा. सेंटर ऑफ अर्थ इज 6400 किलोमीटर्स, तो रेडियस वुड बी 6400 किलोमीटर्स प्लस this height. Done? समझ में आई ये चीजें? Orbits. Let's solve some questions. We have some past year questions also, and some questions that I have framed. We'll solve all those questions. All of you have question set 1. In question set 1 we have 50 questions. Please, जिनके पास नहीं है वो टेलीग्राम चैनल से ले लेंगे. I'll display the questions and we'll solve them one by one. Okay, let's go for question number 1. Let me see answers. Question number 1. Give me the answer here. Delta is asking, sir, will the class be uploaded in portal because my internet connection is not good? हाँ, this class would be there on YouTube ना. Portal पे जाए ना जाए, YouTube पे तो रहेगा ना. You watch whenever your internet connection is good. Okay, give me the answer. देखो, first part का geostationary satellite is at approximate height of 10,000 kilometers. Is it correct? No. Geostationary satellite is at which height? 35786 और 36,000, approximately 36,000. One is wrong. अभी हमने second वाला part करा नहीं है, तो forget that. But one is definitely wrong. Let's go to question number 2. Question number 2. अरे ये तो बहुत बड़ा हो गया. Satellite used for telecommunication relay are kept in geostationary orbit. A satellite is said to be in ये 2011 में आया था. A satellite is said to be in geostationary orbit when, इनमें से क्या क्या satisfy होना चाहिए for a satellite to be in geostationary orbit? 1, 2, 3, 4 में से. Sandeep. Geostationary, geosynchronous, circular है तो geosynchronous भी होगा, and then orbit lying above equator. This is wrong. Height should be 35786 or 22,236 kilometer, नहीं miles. 22,236 miles is equal to roughly 35,786 kilometers. Okay, so this, because of this kilometer thing, it becomes wrong. Answer is 1, 2 and 3. Answer is 1, 2 and 3. Answer is A. I hope सबको समझ में आ रहा है. देखो, अब now you'll understand why did I spend so much time on geosynchronous. ये एग्जाम में आया है question. They asked this question in the examination. Question number 3. Guys, when people are answering it online, please also put question number. कि आप 3 का आंसर A दे रहे हैं या 3 का आंसर B दे रहे हैं, and so on. Question number 3. Question number 3, guys. I haven't seen any answer. An artificial satellite orbiting the Earth does not fall down. जो satellite है जो Earth के around घूम रहा है, that does not fall down. This is because of the attraction of Earth. Does not exist at such distance. क्या Earth का attraction, Earth का gravity does not exist to that satellite? It is there. It is there only then it is able to revolve. Na? If gravity was not there, then it would have not revolved. Right? Only the gravity of Earth is ensuring, attraction of Earth is ensuring that it is revolving. So one is wrong for sure. It is neutralized by the attraction of Moon. It is also wrong. Gravity has to be there. If it was neutralized, then it would not have revolved. Right? आपको समझाया था ना? Provides the necessary speed for its steady motion. Provides the necessary acceleration for its motion. Provides the necessary speed for देखो, what is gravitational gravity? It's a force. Force provides what? It provides acceleration. Force is equal to mass into acceleration. What is force? Force is equal to mass into acceleration. What is acceleration? Change in velocity. Is the velocity of uh, satellite changing? Yes, it's changing. Velocity का change का मतलब direction change होना भी change होता है. What is happening? Let's say this is Earth. Sorry. Earth orbit. यहाँ पे satellite है. Earth का gravity is pulling it in the downward direction, and that's why it changes its velocity to this direction. थोड़ा इसमें वर्टिकल कंपोनेंट भी आ रहा है, थोड़ा इसमें और वर्टिकल कंपोनेंट आ रहा है, और वर्टिकल कंपोनेंट आ रहा है. यहाँ पे इट हैड दिस हॉरिजॉन्टल कंपोनेंट, इट गॉट दिस वर्टिकल कंपोनेंट. तो इट इज एक्सेलरेशन. Change in velocity. Initial velocity was in this direction, then the velocity's direction became this, then it became this, then it became this, then it became this. So what it is providing the necessary acceleration for its motion. Answer is D. Question number 3 ka answer is D. It's not C. A lot of you said C. It is answer is D. Let's go to question number 4. फोर का आंसर पीपल हैव स्टार्टेड गिविंग बी और सी. अच्छा, कुछ लोग बी बोल रहे हैं, कुछ लोग सी बोल रहे हैं. लेट्स सी. कंसीडर द फॉलोइंग. इट्स अ टाइप ऑफ जियोसिंक्रोनस ऑर्बिट. सन सिंक्रोनस पोलर ऑर्बिट जियोसिंक्रोनस थोड़ी है. सन सिंक्रोनस पोलर ऑर्बिट इज अ लो अर्थ ऑर्बिट. सन सिंक्रोनस कहां पे पढ़ा था हमने? लो अर्थ ऑर्बिट वाले सेक्शन में पढ़ा था. Geosynchronous would be those orbits which are at a height of 35,786 km. Sun synchronous was at a height of around 600 kilometers. So one is wrong for sure. It's only possible around oblate planets like Earth. Yes, that is true. So 2 is correct. Answer would be B. Answer would be B. I don't know why people are marking A, C, D. Answer would be B. Question number 4. Answer would be B. Please note down. आपके notes में भी हमने सन सिंक्रोनस पोलर ऑर्बिट लो अर्थ ऑर्बिट में पढ़ा है. सबने पी रखी है, सी कैसे मार सकते हैं? सन सिंक्रोनस पोलर ऑर्बिट इज नॉट अ जियोसिंक्रोनस ऑर्बिट, इज अ सन सिंक्रोनस ऑर्बिट. जियोसिंक्रोनस वाज व्हाट? हाइट ऑफ 35786 किलोमीटर्स. राइट? तो व्हाट विल बी द आंसर? आंसर वुड बी बी. फोर्थ आंसर वुड बी बी. लेट्स गो टू क्वेश्चन नंबर 5. Give me an answer. Question number 5 का. Following statements about satellite orbits. A satellite in circular orbit travels with a uniform speed. Yes. Circular orbit, speed under root gm by r. Elliptical orbit changes its speed as it moves in its orbit. Yes. Elliptical orbit, when it is close to Earth, its speed would be higher. When it is away from Earth, its speed would be lower. What would be the answer? C. Fifth ka C. Let's go to question number 6. Question number 6. Satellites in smaller circular orbit around Earth has higher speed. Sixth, guys, I need answer for question number 6. A. Yes. 6 का आंसर इज A. A, yes. Satellite in smaller circular orbit around Earth has higher speed when compared to satellite in larger. जो छोटा होगा पास में होगा उसका स्पीड हायर होगा. Satellite in smaller circular orbit has lower angular velocity. Angular velocity क्या है? आप कितने देर में 360 डिग्री कंप्लीट कर रहे हो? तो the one which is smaller will complete it faster. No. So satellite in smaller circular orbit will have higher angular velocity. Angular velocity 360 degree in 2 hours or 360 degree in 24 hours. What is faster? 360 degree in 2 hours. Angular velocity is higher here. So low Earth orbit 360 degree in 2 hours. Geosynchronous orbit 360 degree in 24 hours. So which has higher angular velocity? 360 degree in 2 hours. Answer would be A. Let's go to question number 7. Question number 7. सेवन का आंसर नहीं मिला मुझे अभी तक. डी. ओके हाँ डी होना. ये 1 2 3 4 को लिखा है. हाँ दिस शुड बी ABCD गाइस. 3 satellites placed at 120 degree from each other in geostationary orbit can ensure that every point on the surface of Earth can have at least one of the 3 satellites in line of sight. देखो geostationary orbit exactly above equator, geostationary orbit, geostationary orbit. मैं अर्थ हूं चारों तरफ geostationary, geostationary, geostationary. These 3 satellites can cover almost entire Earth. पूरा अर्थ कवर हो जा रहा है. Geostationary orbit is very far away. It's covering almost 1/3 of the Earth. This covers 1/3 of the Earth. This covers 1/3 of the Earth. This covered 1/3 of the Earth. So it can cover entire Earth except polar region. हमने बताया ना पोल्स को नहीं कवर कर पाएंगे बिकॉज पोल्स के यहाँ थोड़ा जियोइड वाला शेप की वजह से. एंड दैट्स व्हाई यहाँ पे देखो 3 satellites placed at 120 degree from each other in geostationary orbit can ensure that every point on the surface of Earth, every point is not getting covered. Geostationary orbit cannot cover polar region. So one is wrong. One is wrong. Almost तो it's fine. But यहाँ पे specifically मैंने क्या लिखा है? Every point on Earth. Every point is it should be able to cover North Pole and South Pole also. So one is wrong. Communication satellites are put in geostationary orbit because it leads to lower latency. नहीं, latency क्या है? Communication में कितना time लगता है? Communication satellite low Earth orbit से के साथ communication में कम time लगेगा ना, latency कम होगी. Geostationary orbit के साथ communication में तो ज्यादा time लगेगा because signal has to travel long distance. Communication satellites are put in geostationary orbit because it leads to lower latency and data loss. No, this is wrong. Geostationary orbit में there is higher latency and data loss, but communication satellites are put in geostationary orbit because why is it put in geostationary orbit? Because antenna does not have to move. Satellite could be tracked easily. This is also wrong. So answer is, what is the answer here? D. Most of you are right answering D. Answering it D. That's nice. Yes, answer is D. Let's go to question number 8. Which of the following spacecrafts are placed in low Earth orbit? अब देखो हमने पढ़ा नहीं है, but roughly I have explained you what are the things which go in low Earth orbit. Try it. Which of the following satellites go in low Earth orbit? Low Earth orbit में generally क्या जाता है? Earth observation satellite, image making वाला satellite, image taking वाला satellite, remote sensing वाला satellite. Because the nearer you are to Earth, the better it is. So give it a try. See, yes. Now Cartosat, Carto map making, yes. GPS, we have just studied, it goes in medium Earth orbit. IRNSS, it is in geostationary, geosynchronous orbit. International Space Station, हमने बोला है, all the human space flight except the one going to moon are in low Earth orbit only. International Space Station is also located in low Earth orbit. Answer is 1 and 4. So here the purpose is not to make you cram which are the things where are these things located. The purpose is to ensure that you're able to understand the logic behind it, so that in exam when questions would be asked which would be factual, you'll be able to apply some logic to deal with those factual questions as well. Let's go to question number 9. Consider the following about geostationary transfer orbit. Nine के आंसर आने लगे. B, A, okay, let me see. It's a home and transfer orbit used to reach geosynchronous or geostationary orbit. One is correct. It's a circular orbit. No, it's a elliptical orbit. Geostationary transfer orbit is an elliptical orbit. हमने देखा था ना? It's not a circular orbit. It was an elliptical orbit. So 2 is wrong. Incorrect पूछा है. Incorrect पूछा है. What is the answer? B. 2 is wrong. 2 is incorrect. Answer is B. Ninth का answer is B. Yes, most of you are answering it B only. Nice. Let's go to question number 10. Question number 10. एयरक्राफ्ट के साइड पे उड़ते हैं. प्लेन्स किस हाइट पे उड़ते हैं? प्लेन्स जनरली 8 से 14 किलोमीटर के बीच में उड़ते हैं. एंड सैटेलाइट ऑर्बिट कर रहा है, अगर एक सैटेलाइट फंक्शनिंग ऑर्बिट कर रहा है तो मिनिमम हाइट क्या होगा उसका? 160. बिलो दिस तो इट कैनॉट ऑर्बिट, इट विल फॉल बैक ऑन अर्थ. तो अ प्लेन कैनॉट क्रैश विद एन ऑर्बिटिंग सैटेलाइट बिकॉज दोनों अलग अलग हाइट पे होते हैं. क्वेश्चन नंबर 1. अब airplane can't crash with a functional orbiting satellite as the height of the flight of the airplane from the surface of Earth is around 10 kilometers, whereas the height of the orbit of the satellite is at least around 160 kilometers. So correct है ये? Yes, 1 is correct. Second, satellite of both GPS satnav and Galileo satnav are located in medium Earth orbit. ये correct है? Yes. देखो आप लोग ना ध्यान नहीं देते हैं. अभी हमने पढ़ा था ना, देखो कंपस, ग्लोनास, जीपीएस, गैलीलियो, मोस्ट ऑफ दीज आर इन मीडियम अर्थ ऑर्बिट. मैंने बोला बाइडू भी मीडियम अर्थ ऑर्बिट में है. व्हाट इज नॉट देयर इन मीडियम अर्थ ऑर्बिट? IRNSS, इंडिया का रीजनल नेविगेशन सैटेलाइट सिस्टम. वी हैव पुट इट इन जीपीएस. तो वी हैव पुट इट इन जियोसिंक्रोनस. तो 2 is correct. 1 is also correct. What should be the answer? Answer should be C. Fine. Answer should be C. Now let's go to question number 11. Why are satellites generally launched from near the equator? ये भी समझते हैं, ये भी पढ़ते हैं. ठीक है, चलिए let's go to let's understand some more things in your notes. I'm sorry. We'll go to rest of the sections. अच्छा, जो लोग अभी तक क्लास देख रहे हैं, प्लीज आपको अच्छा लग रहा है तो सब लोग लाइक कर दीजिएगा. And please share this video with your friends who want to take a demo on how will we be teaching in the Target Prelims Current Affairs program. अभी तक current affairs शुरू नहीं हुआ है. The first 2-3 hours went on understanding the fundamental thing. Then I'll jump on to the current affairs section. Okay, so please do like the video and do share it with your friends, whoever want to see a demo and all. Okay, let's go to. We have studied about orbits. I hope you have clarity on this overall topic of orbits. Now we'll be talking. I'll just give you a broad overview of what are the various things that we have done throughout the year in the field of space, right? So 1962 में our National Committee for Space Research was formed. This National Committee for Space Research was formed under the leadership of Vikram Sarabhai, who is considered the father of India's space program. ISRO नहीं बना था, ISRO बहुत बाद में बनेगा 1969 में. India's first rocket was a sounding rocket that was launched in 1963. In 1975, India's first aircraft, India's first satellite, Aryabhat. या आप बचपन में जो GK books that you study, there you study that India's first satellite was Aryabhat. But it was India's first satellite which was launched using Russian rocket. We had not developed a rocket which is capable of launching satellites. Then Bhaskar was first remote sensing satellite built by India. In 1980, we launched satellite launch vehicle. This was our first generation rocket, which will be able to launch satellites. Later, second generation में advanced satellite launch vehicles would come. In 1982, India launched INSAT, its first major communication satellite. This launch failed. It was abandoned in 1983, where its altitude control failed. In 1984, Rakesh Sharma, a pilot of Indian Air Force, became the first Indian in space. In 2008, India launched Chandrayaan-1. Chandrayaan-1 was a mission where, देखो अभी Chandrayaan-2 was a mission where we had an orbiter which will revolve around, orbit around moon, and then we had a lander which was supposed to land on moon, and then a rover which was supposed to study the surface of the moon. तो अभी जो Chandrayaan-2 में failure हुआ था ना, वो सिर्फ लैंडर वाले पोर्शन का होता. Orbiter is still working. So Chandrayaan-1 also had an orbiter, and it was pretty successful. It was one major achievement that India had. In 2013, we launched Mangalyaan. In 2016, IRNSS, Indian Regional Navigation Satellite System, was fully functional. इसके सैटेलाइट 2013-14 से डल रहे थे, तो 7 सैटेलाइट 2016 तक कंप्लीट हो गए थे. Then in 2019, Chandrayaan-2 is something that we launched, and in 2012 we have plans to take humans to space. We have in 2022 we have plans to take humans to space. We are planning Gaganyaan, where for the first time Indians from India would be going to space. Now ये रफ टाइमलाइन इसलिए दिया है कि आपको थोड़ा पता रहे कि हमने क्या क्या अचीव किया है. Now there are some basic things that I want to cover. One is, why are satellites, अच्छा, by the way, let's first map the satellite launch locations. This is equator of the earth. This is India. India में जो, अच्छा, India is not that far away from equator. Let me draw it a bit near equator. इंडिया में यहाँ पे है, we have श्रीहरिकोटा. पुलिकट लेक के पास है श्रीहरिकोटा, which is on the border of Andhra and Tamil Nadu. This is our satellite launch pad. See, we have tried to come as close to equator as possible. Similarly, if you'll go to USA, तो USA का roughly ये shape होता है, and it has a state called Texas, जो जिसका यहाँ पे ये पोर्शन निकल रहा होता है. In USA also, there space में जो launch site है ना, जो the place from where they launch satellites is here in Texas. In case of Europe तो northern hemisphere में है. In case of Europe also, the European Space Agency in South America, there's a country here, French Guiana. वहां पे अब उन्होंने अपना space station बनाया है. So what you see is space station ही satellite launch pad बनाया है. What you see is most of the satellites are launched from near the equator. They're not launching it from there. They want to launch it from near the equator. And most of the satellites are launched from the east coast. Satellites are being launched from near the equator, and they're being launched from east coast. Why? First, let's understand why satellites are being launched. In तीनों examples, did you understand that satellites are being launched from near the equator? Why are they being launched from near the equator? This is Earth. Earth is rotating. Now think of this point on Earth. In 24 hours, it's covering this distance. Think of this point on Earth. In 24 hours, it's covering this distance, rotation. Think of equator. In 24 hours, it's covering this distance. तो 24 hours में ज्यादा कौन ट्रैवल कर रहा है? Point which is near the equator. तो surface speed किसका ज्यादा है? Point which is near the equator. In 24 hours, it's covering 2 kilometers, it's covering 4 kilometers, it's covering 6 kilometers. So which has higher speed, surface speed? So Earth, near the equator, the surface of Earth is moving much faster. When you are launching a satellite, and already जो आपका surface है ज़्यादा तेज चल रहा है, तो satellite will get an advantage. When you get down from a running, moving bus, you are given an initial speed by the bus only. In the same way, when this satellite is launched, and if the Earth is already moving, satellite would get initial speed, initial support. That's why most of the satellite launches take place from near the equator, because surface of the Earth is moving fastest near the equator. First part. Second, why from east coast? Go back to the image here. देखो सब ईस्ट कोस्ट के पास आके लॉन्च कर रहे हैं, not from the west coast. It's because Earth is moving from in this direction. Earth is moving from east to west, नहीं west to east ना. Sun east to west जाता है तो Earth west to east हो ना. Earth is moving from west to east, right? तो we will be launching satellite. Earth के launch के direction में launch करोगे ना, west to east. Now, when you launch satellite from west to east here and something goes wrong, the satellite falls in the ocean. But if you were launching it from west coast and in this direction, because Earth का movement उस direction में, तो and if something goes wrong in the rocket, what would happen? It will fall on ground. आपने यहाँ मैंगलोर से लॉन्च किया, वो बैंगलोर पे जाके गिर जाता एक्सीडेंट के केस में. Whereas in this case, when you're launching it from the east coast, if something goes wrong, where would it fall? It will fall in the ocean. Here, if something goes wrong, where would it fall? It will fall in the ocean. If something goes wrong, where would it fall? It will fall in the ocean. If it was launched from here and something went wrong, it would have fallen on the land, would have created problem. Got it? So let's go back to the question. Why are satellites generally launched from near the equator? एक, Earth's surface velocity is highest near the equator. That's true. Second, in case of geostationary satellite, very less change would be required to make satellite reach a 0-degree inclination. Geostationary satellite has to reach equator. Uska circular orbit is above equator. So that is another advantage. So both 1 and 2 would be the answer. Answer would be C. So with this, we are done with the orbits. Questions related to orbits. We have also seen that UPSC in the past have asked questions related to this. They may ask it again. I've tried to cover as many things as possible. So 11th answer would be C. Sir, please answer this. It is creating confusion. What is creating confusion, Vani ji? Vani ka, sir, how can we see pole region if geostationary satellite can't? Geostationary India, दूसरे सैटेलाइट्स हैं, जियोसिंक्रोनस हैं और लो अर्थ ऑर्बिट वाले सैटेलाइट है जो पोल टू पोल ही जा रहे हैं, they'll be able to see pole, right? तो geostationary cannot do that, but other satellites do. 11th answer is C. Okay. Shriram is asking for a break. Break चाहिए क्या? मैं बीमारी से उठ के आया हूं, मैं पढ़ा पा रहा हूं, आप लोग थक गए क्या यार? कैसे बनोगे ये ऐसे? Okay, 11th answer is C. Let's take a break then. 20 minute का break लेते हैं. It's 12:10 right now. We'll be back at 12:30. Break 12:10 से 12:30 तक. We'll be back at 12:30. We'll do rest of the booklets and we'll solve rest of the questions. Okay. अब ये नो 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 कौन बोल रहे हैं? ब्रेक नहीं चाहिए? चाहिए कि नहीं चाहिए ये बताओ. चलो अब ले ही लेते हैं जो भी है। ठीक है गाइस, I'll see you at 12:30। 20 मिनट्स का ब्रेक है आपका। Good afternoon, friends. Welcome back. Let us start the session here. We'll now in this section, our focus would be on understanding ISRO rockets. Okay. Shubh is asking, sir, handout does not have answer key. Please provide answer key as well. Beta, answer key to we are providing, no? We in the classroom we are discussing answers, no? The idea is you should go through classes, and that's why we haven't provided answer key, and we won't be providing it. So as part of class discussion, we'll be discussing each and every question. Do not worry. Okay. So we'll now be going to rockets. Now, when we're talking about rockets or rockets by ISRO, there are three broad categories of rockets that we have. We have PSLV, we have GSLV, and we have sounding rockets. In this, PSLV and GSLVs are the ones which are used for launching satellites. Sounding rockets are used for experiment purposes. So we would talk about that also in the coming sections. So first, let's start with PSLV. There are lots of news related to PSLV. News we'll look at later, but for now, first start with the basics. Okay, PSLV क्या है? Or rather than PSLV क्या है? Even before that, let's start with how do a rocket function? What are the key components of the functioning of a rocket? How do rockets function? See, there are some key things that you should keep in mind. Let's say this is Earth, and yahan se you have to launch a rocket. This rocket will take a satellite with it. This satellite has to be launched in an orbit. This satellite has to be launched in this orbit. The rocket will take the satellite to this place. Now, understand the issue. Issue is this, that very near Earth, what is the formula for gravitational force? It is Gmm by r square. So very near Earth, where r is less, gravitational forces is very high. As you go away from Earth, gravitational force is lesser. As you move further away, gravitational force decreases. So initially, when you are at the ground level, you need very powerful engine. But as you go up, you need a very small engine. You do not need that powerful an engine. Sir, please raise the volume. Guys, is volume a problem with everyone? Darpi Chaudhary ji is asking about the volume. Is volume a problem for everyone, or is it okay? Please confirm it in the chat. I'll go accordingly. Is volume a problem? No problem. Okay. Thank you, guys. Darpiji, there may be some issue on your side. Okay, great. So what I was saying was that initially we need a very powerful rocket engine, which will need to burn a lot of fuel. But as the rocket goes on the upper part, you will need a less powerful rocket. Now, in this scenario, the problem that occurs is this. If you go with a very large rocket, after some time, you would not need it. You would not want it. Here, the amount of fuel that heavy rocket will need to burn will be much lesser. And the weight of this rocket, weight of this engine would be unnecessary problem. So in space technology, what we do is we have multiple engines in our rockets. For example, PSLV goes with 4 different stages, where the first stage will be a very large engine, very powerful engine, very strong engine. It will provide a lot of thrust. After going to a particular height, this engine would be disconnected. It will fall back on Earth. Second engine will come into play, which will be smaller. which can provide lower thrust and will thus have lower weight. After going to a particular height, the second engine would also not be needed. We can work with a much smaller engine. The second engine will also fall back. Then third engine will also fall back. Fourth engine, in case of PSLV, there are 4 engines. Fourth engine will go to this orbit and will start revolving. And while it is revolving at a speed of under root gm by r, so that it can remain in a circular orbit, it will slowly release the satellite. It will release the satellite into orbit. This is a crucial aspect. This is a crucial aspect. Sir, please tell after the class this PDF will be updated on regular basis, means if finishing the portion in Feb. What about news related to science and Arey bhai, Atul, let that be my concern. No, I'll update you each and everything. Aap bas अच्छे से पढ़ो. ठीक है? Come back to this. Did you understand the need of 4 different engines? First stage, very powerful engine. Second stage, not so powerful. Third stage, not so powerful. Last stage, it does not need a lot of thrust. Even a small engine would be good enough. Understand it in this manner. Why do we need to drop these engines? Drop these stages? The reason is, let's say you want to ride a scooter. From your home to office, you want to ride a scooter. अगर उस स्कूटर में हम एरोप्लेन का इंजन लगा देंगे, will that scooter be efficient? No, you do not need that huge engine. You only need to travel at 40 kilometers per hour or 50 kilometers per hour, and a small engine would be good enough. You only need to burn a very small amount of fuel. तो जो एयरक्राफ्ट का इंजन अगर आप उस स्कूटर में लगा दोगे, then that would be unnecessary weight that scooter will have to carry. And that's why whenever we do not need a particular engine, once its responsibility is done, the engine keeps dropping. So this is how the satellite, a rocket works. So in reality, what happens? A rocket goes like this at a particular height. First stage falls, second stage ignites, second engine ignites. Then second stage, after reaching more height, second stage falls, third stage ignites, third stage falls, fourth stage ignites, and then fourth stage or the last stage. In case of PSLV, fourth stage is the last stage. In case of GSLV, third stage is the last stage. Takes the rocket into orbit. So what is PSLV? PSLV is the third generation satellite launch vehicle of India. PSLV is the third generation. इससे पहले there were 2 generations of satellite launch vehicle, SLV satellite launch vehicle and ASLV advanced satellite launch vehicle. PSLV is the third generation. This satellite was developed for the purpose of, look at the full form of PSLV. What is PSLV's full form? Polar Satellite Launch Vehicle. So this rocket was primarily developed to launch our Earth observation satellite into what? Into sun-synchronous polar orbit. Earth observation satellite, sun-synchronous polar orbit. Are you able to see the connectivity? Earth observation satellites generally go in sun-synchronous polar orbit, right? So this rocket was primarily developed to launch satellites into sun-synchronous polar orbits. Okay, but PSLV is also capable of launching smaller satellites into GTO. देखो GTO में जाने के लिए क्या करना पड़ेगा? Geostationary transfer orbit. You need a more powerful engine. GTO orbit is used to transfer a satellite to geosynchronous or geostationary orbit. So this PSLV is not only capable of launching satellites into sun-synchronous polar orbit, that is low Earth orbit, but कुछ छोटे satellites को ये geostationary transfer orbit में भी डाल सकता है. It is the third generation satellite. देखो SLV, satellite launch vehicle, advanced satellite launch vehicle, and PSLV. First generation, second generation, third generation. GSLV is fourth generation, and GSLV Mk III is fifth generation of the satellite. Now, so far, PSLV has had 53 launches. 1990s में ये शुरू किया इसने काम करना, and since then it has had 53 launches, and it has made 51 successful launches. So it's a highly accurate, highly efficient satellite launch vehicle. 1990s में develop हुआ था. आप देखेंगे till February 2021, which was PSLV C51. PSLV C51 was 53rd launch. PSLV C50 was 52nd launch. PSLV C49 was 51st launch. तो PSLV C51 was 53rd launch of satellite. उसके बाद PSLV का launch नहीं हुआ, इसलिए latest news about PSLV is also that we are getting from this the February 2021 only. Other than in these 53 launches, it has launched more than 342 foreign satellites as well from 34 different countries. Now, what are some of the technical specification of PSLV? एक है two sun synchronous polar orbit. Do we understand what is sun synchronous polar orbit? Two sun synchronous polar orbit is a low Earth orbit. It can carry a satellite weighing up to 1860 kg. The maximum payload that it can carry, the maximum weight of the satellite that it can carry to sun synchronous polar orbit is 1860. But to GTO, will it be able to carry this big a satellite? No. GTO में तो ज़्यादा स्पीड से लॉन्च करना पड़ेगा ना सैटेलाइट को for it to go to GTO. तो to GTO it can launch a satellite only up to 1425 kg. So if you have to launch a communication satellite which is more than 1500 kg का weight in GTO, PSLV will not be usable. PSLV can launch a satellite in SSPO which is weighing up to 1860 kg. PSLV can launch a satellite in GTO which is weighing up to 1425 kg. ये क्लैरिटी है, सबको समझ में आ रहा है? ओके. Now there are some features of PSLV engine. PSLV has 4-stage engine. First stage uses solid fuel, that's why we call it solid engine. Second stage uses liquid fuel, we call it liquid engine. Third stage again solid fuel. Fourth stage again liquid fuel. We'll understand the reason why we have gone for this hybrid approach. As I was telling you in the beginning, the first stage is very powerful stage, and you'll see its maximum thrust is 4800 kilonewton. Thrust is the force that it can apply. So the maximum thrust of the first stage is 4800 kilonewton. Compare it with the second stage, 800 kilonewton. Compare it with the third stage, 240 kilonewton. Compare it with the fourth stage, 7.4 kilonewton. So when our rocket is at a very large height, their gravitational force of Earth is very less, and therefore it does not need very powerful engine. Engine with a very less thrust would also be good enough. Here, 700 times more on the surface of Earth, PSLV uses 700 times more powerful engine when compared to what is needed at a height of 300, 400 or 500 kilometers. Did you understand this? PSLV has 4-stage engines, solid, liquid, solid, liquid. Solid engine में the fuel that is used is hydroxyl terminated polybutadiene. Liquid engine में the fuel that is used is UDMH, unsymmetric dimethyl hydrazine. Okay, इतना डिटेल में समझने की जरूरत नहीं, but PSLV के 4-stage engines should be clear to you. Now, this is an interesting thing. PSLV, if you'll go to the definition of PSLV again, PSLV is a 3rd-generation engine. It's an expandable system. Look at the term, expandable system. What is meant by PSLV being expandable? So, देखो, PSLV is a rocket. PSLV is a rocket which has engine 1, engine 2, engine 3, engine 4. I have explained you the purpose of these engines already. Right? Now, engine 1 is the most powerful one, and it carries a satellite also. Satellite जो इसे launch करना है. PSLV is a rocket which will carry the satellite. Engine 1 is the most powerful. So if it has to carry a heavier satellite, सबसे पहले हमें जिससे strong करना पड़ेगा, that is engine 1. So PSLV allows attachment of what are called strap-on motors. Strap-on. So 6 strap-on motors could be attached to PSLV's first stage to give it higher capacity. तो PSLV alone is called PSLV core alone, PSLV CA. PSLV with 6 strap-on motors is called PSLV G. PSLV with 6 strap-on motors, but those strap-on motors are very powerful, more powerful, extra large. It is called PSLV XL. Are you getting it? So PSLV core alone PSLV, then PSLV with strap-on motors, PSLV G, PSLV with large strap-on motors, extra large strap-on motors, PSLV XL. तो इसमें भी 6 motors, इसमें भी 6 motors. What if we need something in between? We also have what is called PSLV DL and PSLV QL. 2 motors, 4 motors, 6 motors, and 6 extra large motors. So PSLVs 5 variations. Did you get it? 5 variations of PSLV. Now, it is, हमने बोला ना कि PSLV can carry a weight of up to 1800 kg roughly to SSPO and roughly 1400 kg to GTO. It is the capability of PSLV XL. PSLV G can only carry 1678 kg to SSPO, and PSLV core alone can only carry 1100 kg to SSPO. तो आपको 1100 1600 के बीच में जाना है, you either go for PSLV DL or PSLV QL. Fine. Now, let me again come here. Is this clearly understood? एक तो PSLV core PSLV core alone. It can carry a weight of up to 1100 kg to orbit. इसका खुद का weight बहुत ज्यादा होता है, fuel का weight भी बहुत ज्यादा होता है, but the satellite that it can carry is very small, only around 1100 kg. You add 6 strap-on motors and make it PSLV G, roughly around 1600 kg it will be able to carry to SSPO, sun synchronous polar orbit. You add extra large motors. यहाँ पे भी 6 motors है, यहाँ पे भी 6 motors है, but these 6 motors are extra large. It becomes PSLV XL. It can carry 1700-1800 kg of weight to space. This 1100 kg. 1100 और 1600 के बीच में we have PSLV DL and PSLV QL, the 5 variations of PSLV. Now, PSLVs have been very successful. The PSLV is considered workhorse of ISRO. Most of the important launches that we have made, चाहे वो चंद्रयान 1 2008 में हुआ हो, मंगलयान 2013 में, IRNSS, India का regional navigation satellite system, Cartosat series of satellites and all, everything has gone through PSLV. Of the major achievements by ISRO, only one, Chandrayaan 3, was done by GSLV Mk III, else everything went through PSLV. PSLV is the workhorse of ISRO. PSLV has been very accurate. So far there have been 53 launches of PSLV, 51 have been successful. एक तो सबसे पहला गड़बड़ किया था और एक 2016-17 में एक फेलियर हुआ है. Otherwise, out of 53, 51 launches of PSLV have been very successful. Fine. Now, it has commercial uses also, as I've told you. Already 342 foreign satellites we have been able to launch. On our rockets, other satellites have gone, and it enhances India's soft power. Now, kuch extra gyan. Solid engine, liquid engine, solid engine, liquid engine. We spoke about that. No, before I get into this extra gyan, let me take the doubts. Silver Raj is asking, it is not advanced SLV, it is augmented SLV. Okay. ASLV is augmented SLV as per Kishore Raj Silver Raj. Then SS is asking, sir, may you please tell why is sun synchronous orbit always polar? Actually, we'll go back to sun synchronous, then we'll discuss it. Abhi PSLV में जो doubt है वो पूछिए. Sir, please explain the concept once again. Which concept, beta? Can you please explain the same strap-on motor wala concept again? Okay. Sir, what is the strap-on motor? Okay, Vani and Prachi are asking about strap-on motors once again. Understand it in this way. Suppose you have a car. You have a car. That car has a particular engine. Usse it can carry some weight. You want to strengthen your car further. So you add some more engines to it. So these strap-on motors are those extra motors that get added. So PSLV by itself, PSLV rocket by itself is called PSLV core alone, and it can carry a satellite of up to 1100 kg into sun-synchronous polar orbit. But when to this PSLV core alone, you add 6 more motors, it becomes PSLV G, and its capacity becomes around 1600 kg. Similarly, if you add 6 strap-on motors here, 6 large strap-on motors, it becomes PSLV XL, and its capacity becomes roughly 1800 kg. So this is extra motor that is getting added. Okay. I hope strap-on motors wala concept samajh mein aaya. Then Renu is asking, sir, what are ramjet and scramjet engine? Bhai, aayenge na. We'll talk in today's class only. We'll talk about ramjet, scramjet engine. Do not, if you have doubt in PSLV abhi, ask that. If I'll start explaining you what is ramjet engine, what is scramjet engine yahan pe, so our study of PSLV would get affected. Sir, please arrange it in increasing or decreasing order. Beta ho gaya na. PSLV CA G XL. Common sense लगाओ. PSLV core alone, PSLV G, PSLV XL. यहाँ पे 6 मोटर्स है. 6 की अगर 2 ही मोटर होते तो it would have been called PSLV DL. 4 motors होते तो it will be PSLV QL. This is the order: core alone, DL, QL, PSLV G and PSLV XL. All 5. I hope समझ में आ रही है चीजें. Fine. तो this is our PSLV engine. Now PSLV की न्यूज देख लेते हैं. करंट अफेयर्स भी तो देखना है, सिर्फ PSLV नहीं पढ़ना ना. Let's go to why PSLV was in news. देखो, PSLV C51, the latest PSLV launch, took place in February 2021. PSLV C51 took place in February 2021, almost एक साल पहले, where it launched Amazonia and 18 co-passenger satellites from Sriharikota. So it was 53rd flight of PSLV. It used PSLV का DL configuration. DL 2 engine वाला configuration, and the primary satellite that it launched was Amazonia, जो ब्राजील का एक satellite था, and उसके अलावा there were 18 co-passenger satellites which were from InSpace and 14 from NSIL. Okay, then PSLV C50 इससे पहले दिसंबर 2020 में लॉन्च हुआ था. It launched CMS-01 communication satellite. CMS is communication satellite. 01 communication satellite. Where would it go? Geostationary or geosynchronous? So it launched communication satellite in geostationary transfer orbit. Transfer orbit, that elliptical orbit. Now satellite went to height, and there maneuvering took place, and it went into geostationary orbit. ये वाली बात समझ में? न्यूज समझ में आ रहा है? देखो, this news is easy to understand once you understand the orbit, geostationary orbit. Why PSLV was launching satellite in GTO? देखो, here PSLV was launching satellite into low Earth orbit. Here PSLV is launching satellite in geostationary transfer orbit. This was PSLV C50 was the 52nd launch of PSLV. C51 was the 53rd launch of PSLV. In C51 we used DL configuration. In C50 we used XL configuration of PSLV. CMS-01, we'll study about CMS-01, a communication satellite, as we come to satellite. Before this, Earth Observation Satellite 1, EOS-1, was launched by PSLV in November 2020. This was PSLV C49. PSLV C49. C49 was the 51st launch of PSLV. C50 was the 52nd launch of PSLV. C51 was the 53rd launch of PSLV. फाइन, ये वाली बात समझ में आ रही है? ओके, तो दीज वर वेरियस न्यूज. दिस न्यूज इज बेटर अंडरस्टूड इफ यू have understanding of fundamentals. Now we will go to solid engine, liquid engine. The doubt. Solid fuel engine versus liquid fuel engine. Let's understand this. Let's understand this concept of solid fuel engine and liquid fuel engine. देखो, you yourself think solid fuel. अब कोयला है, कोयला रखे हुए हो, उसमें आग लगा देते हो, that is solid fuel. Petrol, think of engines, the internal combustion engines in your cars, in your diesel cars or in your petrol cars. Small amount of petrol is provided, that is burned to produce energy. Not all the petrol is burned at one go. Whereas in when you had solid fuel, आप पूरा का पूरा fuel डालते रहते हो, you cannot control. Once the fuel is put, you cannot control how much of burning would take place. So the difference between solid fuel and liquid fuel, the basic most important difference between solid fuel and liquid fuel is this: solid fuel will burn all at one go. Liquid fuel can be controlled. So in situations where you need more control at the higher stages, you need more control, you would want to launch your satellite into this orbit, then you would want to restart the engine and go to higher orbit. You will again want to launch some more satellites there. Then you would want to go to higher orbit, and then you would again want to launch a satellite. So one rocket can be used for launching satellites in multiple orbits. So you need to control, you need to switch off your engine, you need to switch on your engine. But a solid fuel engine में you cannot switch it on or switch it off. Solid fuel में all the fuel will burn at one go. Whereas in liquid fuel engine, you get this capability, this capacity to switch on. पाइप से जहां से फ्यूल सप्लाई कर रहे थे उसे रोक दिया. Solid fuel will not supply by pipe. Right? So when you need a lot of the solid fuel has an advantage that it has very high energy density. कम volume में it will be able to store lots of fuel. Solid is denser when compared to liquid. But liquid gives you control. So when you need when you need a lot of energy to be used, you start with solid fuel. Where did you start with solid fuel? At ground level, you started with solid fuel. First stage of PSLV is solid. After some time, you drop that engine, solid fuel wala engine, you exhaust your solid fuel, you start using liquid fuel, which will give you control. Here you want control because you do not want that your rocket should become keep on increasing its speed, that it achieves escape velocity. Escape velocity is that velocity by which if you throw something from the ground, it will be able to go beyond Earth's gravity. That is escape velocity of Earth. So in the second stage, you want liquid engine so that you will be able to control kitna fuel burn ho. Then in third stage, you again go for solid so that you're able, like third stage is a much smaller engine. Solid engine ensures that solid fuel ensures that कम space में ही बहुत ज़्यादा energy मिल जाए. And in the last stage, you again have liquid, which will give you more control. PSLV के 4 stages. Now, look at the key characteristic. Solid rocket fuel will have higher thrust, ज़्यादा energy provide कर सकता है. Less volume in less space, more of the fuel could be stored. It provides for one-time burn. आपने एक बार आग लगाई तो पूरा fuel burn होगा. You will not be able to control it, and it produces a lot of smoke, large particles when fired. Whereas a liquid fuel engine gives you ability to control thrust. Second, engines can be shut down and restarted, which was not the case with solid fuel. Solid fuel में एक बार आग लगाए उसे बुझा नहीं सकते. Liquid fuel में you can supply the flow of fuel to stop the engine. Higher energy density. Liquid fuel provides you higher energy density per kg of propellant. But एक kg store करने के लिए ज़्यादा space लेगा liquid when compared to solid. But per kg of propellant, it provides higher energy density and it also has higher specific impulse. Okay, Specific impulse is what? Force into time. Higher specific impulse, एक फोर्स इनटू टाइम आप कितने टाइम तक दे सकते हो. तो जनरली लिक्विड इंजन प्रोवाइड्स यू हायर स्पेसिफिक इंपल्स एंड दैट इज व्हाट इज नीडेड फॉर इंजन एट हायर लेवल. एट लोअर लेवल्स यू नीड लॉट ऑफ थ्रस्ट. तो सॉलिड फ्यूल में प्रोवाइड यू लॉट ऑफ थ्रस्ट, बट एट हायर लेवल यू डू नॉट नीड अ लॉट ऑफ थ्रस्ट. यू नीड some amount of force for longer period. And specific impulse is that कि कितने kg fuel में आप some amount of force for longer period. Initially you need a lot of thrust. So initially you will use solid fuel so that you get a lot of thrust. But at higher level you want to maneuver. You want to move around slowly. So you need some force should be available for a period of time. And कौन सा fuel provides it better? Fuel which has better specific impulse. Liquid fuel has a better specific impulse. Fine. So, but liquid fuel has a problem also. Liquid fuel engine is more complicated. Pipes, control system and all. Solid fuel, लाया जला दिया. Liquid fuel, you have to control the supply of fuel. Right? Look at internal combustion engine of car, how complicated they are. In the same way, it's complicated. Thus, fuel is lighter, but the engine becomes heavier. This is a problem. So generally, what the global community has done, it has gone for a hybrid model. Kuch solid engine, kuch liquid engine. Wherever we need more thrust, we'll go for a solid engine mechanism. Wherever we'll need more specific impulse, we'll go for a liquid engine mechanism. So PSLV, solid liquid, GSLV, solid liquid. GSLV basically solid liquid or cryogenic engine hota hai, but cryogenic engine is a type of solid or liquid engine only. So we go for a hybrid engine approach. Fine. So now we have this PSLV C51 का launch जो February 2021 में हुआ था. Its details here. I'm not going into details here. You can study it at your own. Let's talk about GSLV. PSLV. Do we all understand PSLV rocket? A rocket, third generation rocket of India, 4 engines, solid liquid, and the most successful rocket of India. Okay, let me see the doubts. फोर फाइटर्स इज आस्किंग सर आप क्या पढ़ाते हो? यार मैं पूरा करंट अफेयर्स पढ़ाता हूँ, जो भी आप चाहेंगे. साइंस, एनवायरनमेंट, इकोनॉमी, पॉलिटी, सब कुछ मैं ही पढ़ा रहा हूँ उस करंट अफेयर्स में. सर डज स्ट्रैप ऑन मोटर्स आल्सो डिसइंटीग्रेट ऑन रीचिंग हाइट्स? देखो डिसइंटीग्रेट, इट गेट्स डिस्ट्रॉयड व्हेन इट फॉल्स बैक ऑन अर्थ. इट फॉल्स बैक ऑन अर्थ एंड इट गेट्स डिस्ट्रॉयड. सर AL नहीं समझा. QL नहीं. QL बेटा when 4 strap-on motors are used, that is QL. PSLV QL. सपना जी, when 4 strap-on motors are used, that is PSLV QL. Jasbinder Kaur is asking, sir, why PSLV need third engine as solid engine? See, PSLV needs, देखो, she has a question कि sir, you had solid engine initially when a lot of thrust was needed. Then you moved to liquid engine because you wanted some control. Basically, in second stage we moved to liquid engine because अगर हम solid engine ही use करते रहेंगे तो इतना सारा thrust मिल जाएगा उसे, it may achieve escape velocity. But then we again go to solid engine in third stage. The reason is, see, you need some engine which can provide you some kind of thrust, some kind of impulse. Solid engine in smaller amount of fuel will be able to provide you that. Liquid engine, we could have used liquid engine also, but in case of liquid engine, heavier engine would have been used and more fuel would have been used, more space would have been used. And finally, when you have to maneuver a lot, you go for liquid again. Nisha is asking, sir, SLV, how many engines? Beta, you do not need to worry about that. Now SLV is no more being used, or ASLV is no more being used. तो यू डू नॉट हैव टू रिमेंबर दैट डेटा कि कितने इंजन उसमें है। सर पीएसएलवी एक्सेल क्यों, व्हाई नॉट जीएसएलवी? अभी आते हैं ना जीएसएलवी पे, विल एक्सप्लेन दैट। तरुण प्रियांशु, सर हाउ मच मोर फॉर टुडे? अरे पढ़ते रहो ना, जब पढ़ने का देखो, द एडवांटेज ऑफ ऑनलाइन क्लासेस इज जब आपका पढ़ने का मन ना करे रुक जाओ, पॉज कर लो, जब आपका दोबारा मन करे आप पढ़ना शुरू कर दो। दैट्स एन एडवांटेज ऑफ ऑनलाइन क्लासेस ना, दैट्स एक्चुअली अ डिसएडवांटेज, यू पीपल डू नॉट स्टडी सिंसियरली, बट स्टिल। तो आई विल कीप टीचिंग जब तक मन है, जब तक जान है। आप लोग जब मन हो पढ़ लीजिएगा, बस जाने से पहले अपने दोस्तों के साथ मेरा वीडियो शेयर कर दीजिएगा और इसे लाइक कर दीजिएगा, ठीक है? तो I'll teach at least till 2 PM तो पढ़ाते ही हैं, उसके बाद देखते हैं क्या कर सकते हैं। ओके चलिए, तो GSLV, did we understand PSLV? Now see, PSLV XL was the highest capacity PSLV, but to GTO or to SSPO, what is the maximum weight that it could carry? It could carry only 1800 kgs. to GTO वो weight और भी कम हो जाता। to SSPO, to sun synchronous polar orbit, it can carry 1800 kg. to GTO, that weight would have been further less. What if we want to launch a satellite which weight 2000 kgs, 2500 kgs, 4000 kgs, 5000 kgs, 6000 kg? एक सैटेलाइट जिसका वेट 6000 kg है, will PSLV be able to carry it? No. And that's why we developed what is called GSLV, Geosynchronous Launch Vehicle. अभी न्यूज में भी था, अगस्त में एक लॉन्च इसका फेल हुआ था, इस वजह से न्यूज में था। विल कम टू दैट न्यूज, बट फर्स्ट लेट्स अंडरस्टैंड GSLV. GSLV is an expandable launch system operated by ISRO. Now please understand, लॉन्च सिस्टम रॉकेट, एक्सपैंडेबल मतलब यहाँ पे भी स्ट्रैप ऑन मोटर्स, एक्सपैंड कैपेसिटी इसकी एक्सपैंड करी जा सकती है, यहाँ पे भी स्ट्रैप ऑन मोटर्स लगाए जा सकते हैं। GSLV is an expandable launch system operated by ISRO. First launch of GSLV took place in 2001, which was a failure. The PSLV was developed for launching sun synchronous polar orbit satellites. GSLV was developed primarily for launching geosynchronous satellites, communication satellites. Or where would geosynchronous be launched? In GTO, in geostationary transfer orbit or geosynchronous transfer orbit. So GSLV was developed for that purpose, but GSLV has not had the kind of achievements, the kind of successes that PSLV has been able to have. PSLV, 53 launches so far, more than 300 foreign satellites have been launched, 51 have been successful, but that has not been the case with GSLV. GSLV का first launch fail हुआ था. Main purpose, GSLV was primarily developed to launch INSAT class of satellite into geosynchronous transfer orbit. INSAT was our communication satellite series. INSAT series, GSAT series हमारे communication satellite series है. जैसे आप देखेंगे, INSAT were then replaced, were being replaced by GSAT. Now GSATs are being replaced by CMS. हमने भी देखा था CMS-01 was launched by PSLV, right? So INSAT, GSAT, CMS, communication satellite, these are our what? These are our communication satellites. So GSLV was primarily launched for, developed for launching communication satellites. Now, what is its payload to GTO? What is the maximum weight that it can carry to GTO? 2.5 tons, 2500 kg. PSLV SSPO में ही सिर्फ 1800 kg लेके जा सकता था, but it can carry 5000 kgs to SSPO, 5000 kgs to low Earth orbit. GSLV Mark II that we are talking about, it can carry a weight of up to 5000 kg to low Earth orbit, a weight of 2.5 thousand kgs, 2500 kgs to GTO, geostationary transfer orbit. तो देखो, PSLV इसका SSPO में कैपेसिटी क्या है? 1800 kg, राइट? और लो अर्थ ऑर्बिट लिख देते हैं। लो अर्थ ऑर्बिट में इट कैन कैरी अप टू 1800 kg, GTO में up to 1400 kg, right? Come to GSLV Mark II. GSLV Mark II. Low Earth orbit में it can carry 5000 kg. GTO में it can carry 2500 kg. Can you see the difference? GSLV is an advancement. GSLV is an improvement. Sir, how much? Sir, what is the example of solid fuel? Hydroxyl terminated polybutadiene, HTPB, is a solid fuel ka example. Sir, tell us about the various fuels like atom oxygen, ATM oxygen. Oxygen is not a fuel. Oxygen is an oxidizing agent. We'll come to cryogenic engine में जहाँ पे we'll talk about liquid hydrogen being used as fuel and liquid oxygen being used as the oxidizing agent. But let's come back here. PSLV 1800 1400 kg, GSLV 5000 2500 kgs. Okay, now GSLV is a 3-stage launcher. The PSLV में 4 stages थे, solid fuel, liquid fuel, solid fuel, liquid fuel. In the same way, GSLV has 3 stages. First is solid motor stage, second is liquid stage, and third is cryogenic stage. GSLV के 3 stages of engine है, 3 engines है. PSLV had 4 stages, GSLV has 3 stages. GSLV is an expandable system. So the first stage, solid motor stage, could be expanded with strap-on motors, 4 strap-on motors, which are liquid engines as such. Then second stage is liquid engine and third stage is cryogenic engine. So liquid engine you understand, fuel would be liquid. What is cryogenic upper stage? What is cryogenic upper stage or cryogenic stage? Let's understand this. Sir, with strap-on motors 5000 kg है or along GSLV. GSLV with strap-on motors can carry a satellite weighing up to 5000 kg to low Earth orbit. GSLV Mark II की बात कर रहे हैं. Let's talk about cryogenic stage. तो थर्ड स्टेज की बात कर रहे हैं ना हम, क्रायोजेनिक स्टेज. लेट्स टॉक अबाउट दैट. डू यू अंडरस्टैंड व्हाट इज क्रायो? वेरी कोल्ड. तो क्रायोजेनिक इंजन्स आर दोज इंजन्स व्हिच ऑपरेट एट वेरी लो टेम्परेचर, -250 डिग्री सेल्सियस. सोचो यहाँ पे 5 डिग्री सेल्सियस दिल्ली में हो जाता है, हमारी कितनी लग जाती है वॉट? -252 डिग्री सेल्सियस, -253 डिग्री सेल्सियस पे cryogenic engine operate होगा. Now you'll ask, sir, why the hell do you want to operate your engine like that? It's because we want to use hydrogen as fuel. And hydrogen is a gas, right? हमारे around hydrogen हो सकता है, water vapor होते हैं, उसमें hydrogen होता है, but hydrogen is a gas ऐसे. Now gas will take a lot of space. So we convert the gas into liquid. तो वाटर कौन से टेम्परेचर पे गैस से लिक्विड बनता है? 100 डिग्री सेल्सियस. 100 डिग्री सेल्सियस पे वाटर वेपर बनेगा, या 100 डिग्री सेल्सियस पे वाटर वेपर वाटर बन जाएगा, राइट? एट नॉर्मल रूम टेम्परेचर दिस वुड बी द सिनेरियो. हाइड्रोजन गैस रहता है. For hydrogen to become liquid, it needs a temperature of -252 degrees Celsius. So you want to use hydrogen as a fuel because hydrogen is a very good fuel. It has excellent specific impulse. At higher stages, what do you want? Good specific impulse. At lower stages, you wanted thrust. At higher stages, you needed good specific impulse. Hydrogen as a fuel has a very good specific impulse. But hydrogen gas form में तो कितना लेके जा पाओगे? Hydrogen becomes liquid at -252 degrees Celsius. उसको जलाते टाइम hydrogen would be burned with oxygen to form H2O. Oxygen is liquid. Oxygen becomes liquid at what temperature? -182 degrees Celsius. -180 के आसपास कोई टेम्परेचर है. तो हाइड्रोजन एंड ऑक्सीजन आर taken in the liquid form in cryogenic engines. This engine in GSLV is called cryogenic upper stage. First stage solid, second stage liquid, third stage cryogenic upper stage or cryogenic engine. Please note it is also a liquid engine. Hydrogen is liquid fuel. Hydrogen is converted into liquid. Oxygen is liquid fuel. Why are we using it? Because it has much better specific impulse. Okay, I'll get into this specific impulse or impulse में जो आपका confusion हो रहा है. I'll again get into this, but एक एक करके पहले इस पे चल लेते हैं. Let's understand this. Okay, so the cryogenic engine which is used in the GSLV Mark III, GSLV Mark II, GSLV Mark II that we're talking about, that is CE 7.5. This is an engine that we have developed ourselves from the Russian model. Initial GSLVs had engines from Russia. We did not have the capacity to develop our own engine. But then using Russian techniques, we have developed cryogenic engine CE 7.5, which is used in GSLV Mark II. And the fuel, liquid oxygen and liquid hydrogen is used here. So GSLV has, जैसे PSLV के अपने variants थे ना, ऐसे GSLV had many variants. There was GSLV Mark I, उसमें 1A, 1B, 1C था, but they are not important as they are not used anymore. So I'm not getting into its detail. GSLV Mark II, we have discussed everything that we discussed about GSLV so far was about GSLV Mark II. Solid, strap-on, liquid, cryogenic. Cryogenic में we have fuels, solid fuel, liquid fuel. Okay. Abhishek is saying, sir, recently we have started using isocene. नहीं, kerosene का एक version है isocene that is used in semi-cryogenic engine. We'll come to that also. यार अभिषेक चिंता मत करो, एक एक करके आते हैं ना सारी चीजों पे. We'll go to semi-cryogenic engine also. Once you study things systematically, no, it's easier to remember, it's easier to understand. We'll try to remain as systematic as possible. Okay, come back to this. What were we talking about? So you have understood GSLV engine, GSLV Mark II, 3 stages, third stage is cryogenic. Now देखो, अब GSLV Mark II भी to GTO, to Geostationary Transfer Orbit, what is its capacity? कितना कैरी कर सकता है? बोलो बोलो. 2500, 2500 kg. To GTO, GSLV Mark II can carry 2500 kg, but we had satellites, communication satellite, जिनका weight 4000 किलो था, and which we wanted to put in geostationary orbit, which we wanted to put in GTO. So GSLV Mark II was not capable of doing it, and so we were paying a lot of money to other countries to launch our satellites. To solve that problem, we developed GSLV Mark III. GSLV Mark III is an advanced version of GSLV Mark II. Here, it is also a 3-stage heavy lift rocket. First stage, solid rocket boosters है, जहाँ पे you will see the 2 S200 solid rockets boosters are used here. 2 strap-on motors of GSLV Mark II are also located on the other side of the boosters. Then we have liquid propellant core stage. Second stage is liquid stage, and then it also has a cryogenic stage, third stage C25 engine. वहाँ पे C 7.5 engine we were using. That cryogenic engine was the engine that we developed by reverse engineering the Russian version. This is a cryogenic engine, CE20 engine or C25 engine is something that we have developed at our own from basics. And इसका जब आप capability देखोगे, it can carry a satellite of up to 4000 kg to GTO and up to 10,000 kg to low Earth orbit. Let me put this comparison. यहाँ पे था ना PSLV 1800 kg and 1400 kg, 2500 and 5000. Let me put GSLV Mark III here. Mark III, low Earth orbit में 10,000 kg and GTO में 4. Are you understanding how our capacities are increasing with every? This is the most advanced version of rocket that we have right now. GSLV Mark III is the most advanced version of the rocket that we have right now. Most advanced version. PSLV is the most successful one. Chandrayaan 1, Mars Orbiter Mission, IRNSS, जितने हमारे major initiatives थे, other than Chandrayaan 3, Chandrayaan 2. Chandrayaan 2 was with the help of GSLV Mark II. Right? Clarity hai? Okay. So capability 4 ton or 8 to 10 tons in. So far, these are the launches which have taken off GSLV Mark III. सबसे पहले we did an experimental flight where only the first stage was tested. It was an experimental flight. इसमें कोई satellite launch नहीं किया गया था. Then in June 2017 and in November 2018, we launched GSAT 19 and GSAT 29. GSAT 19 and 29 are communication satellite, heavy communication satellites, high throughput communication satellite, which has very good bandwidth. They were launched using GSLV Mark III D1 developmental flight 1, D2 developmental flight 2. Finally, GSLV Mark III से हमने चंद्रयान 2 लॉन्च किया था. It was the first commercial non-developmental flight. देखो, experimental you are testing, developmental आपने develop कर लिया है, but still you are not using it for like वैसे. Here in the process of development you launch 2 satellites. Then GSLV Mark III M1 was used in July 2019 for Chandrayaan mission. Now, why GSLV Mark III is significant for us? There are a number of reasons. It increases India's self-reliance. Earlier, for heavier satellites, we had to depend on other countries. We used to go to European Space Agency, please launch kar do, paise le lo. We used to go to Russia and we used to waste a lot of money. It saves money also for us. It gives us an opportunity of commercialization. See, PSLV has launched 340 foreign satellites, but they have launched small satellites, and launching small satellites do not earn us a lot of money. And we Indians are money minded. पैसा बहुत चाहिए. सिर्फ हम नहीं, पूरी दुनिया को पैसा ज्यादा चाहिए ना. पूरी दुनिया को चाहिए पैसा, तो हमें भी चाहिए. It will get us that money. It will GSLV Mark III will ensure that we are able to earn more money by getting to launch heavier satellites. Then advancement in science and technology, India's soft power is enhanced. When India will be capable of launching heavier satellites, more countries will look up to India. चलो India से भी हम launch करवा सकते हैं. Our soft power would increase. Then future ISRO missions. We are planning to launch Gyan and all. They will be using GSLV Mark III. ISRO is long term is also planning GSLV Mark III to be India's first vehicle to ferry people into space. That is Gaganyaan. Chandrayaan 3.0 will also be perhaps launched using this only. Okay, so GSLV, PSLV, GSLV Mark II and GSLV Mark III. Are you clear about it? Do you understand everything about it? Now, briefly, let's talk about India's journey towards developing our own cryogenic engine. Because one of the recently GSLV का launch हुआ था अगस्त में, which failed. आपने न्यूज में भी पढ़ा होगा, GSLV F10 failed. It was supposed to launch a satellite, it failed. Failure of GSLV F10 cryogenic upper stage. Though जो failure हुआ था, that was because of cryogenic upper stage. First stage and second stage worked properly. Third stage failed to ignite. The failure was because of this particular stage. So let's understand India's journey. So initially, as we were saying, so do we all understand what cryogenic engines are? Cryogenic engine is a rocket engine that uses cryogenic fuel or oxidizer. Its fuel or oxidizer are gases, liquids, and stored at very low temperature. All cryogenic engines are also liquid propellant rockets. That also we have explained you. Fuel, liquid hydrogen minus 259 degrees Celsius and liquid oxygen minus 183 degrees Celsius are the most जो liquid is temperature पे बनेंगे are the most commonly used fuel. Now, developing a cryogenic engine is challenging for a number of reasons. First, it's a sophisticated technology because a super cooled fuel has to be burned at very high temperature. Hydrogen is at minus 259 डिग्री सेल्सियस और उसको बर्न करके आपको हीट प्रोड्यूस करना है. It's a complicated thing in itself. Similarly, a material that can withstand high temperature and pressure combustion is also challenging. देखो, you have to have a material which can withstand very low temperature, very high temperature, sudden spike, उस तरह की चीजें. Because of these challenges, developing a cryogenic engine itself was problematic. So initially we took cryogenic engines from Russia, but now in GSLV Mark II we have cryogenic engine 7.5, which we have derived from Russian engine only. And then in GSLV Mark III we have cryogenic engine 20, which we have developed at our own from scratch. Fine. Cryogenic engine कहाँ क्या हो रहा है वो क्लियर है. Now GSLV F10 क्यों फेल हुआ? क्योंकि क्रायोजेनिक अपर स्टेज नहीं वर्क हुआ. नाउ GSLV F10 इज बेसिकली जैसे हमने PSLV C51 PSLV C50 देख रहे हैं ना, दे वर वर्जन्स ऑफ PSLV ओनली. तो GSLV का एक लॉन्च था GSLV F10 वेयर अर्थ ऑब्जर्वेशन सैटेलाइट 03 was supposed to be launched into orbit, but it was not able to do it as the third stage did not function properly. So scientists are worried कि first experts got worried कि अरे इसका cryogenic engine fail हुआ. In future will the cryogenic engine of GSLV Mark III also create problems for us, because it is GSLV Mark III with which we are planning Gaganyaan, with which we are planning Chandrayaan 3.0. So experts say that no, GSLV Mark III is using a different engine, C20, which we have developed from scratch. It is not a reverse engineered version of the Russian engine which is being used in GSLV Mark II. फेलियर जो हुआ है वो C7.5 का हुआ है, क्रायोजेनिक इंजन 7.5, which is a reverse engineered version of the Russian engine. Okay, so do not worry. This is what experts say. But this failure will definitely impact other missions. There's a NISAR mission. We'll study about NISAR mission, which is supposed to be done with GSLV Mark II. Now GSLV Mark II बार-बार फेल हो रहा है. अपने पहले रॉकेट लॉन्च में फेल हुआ, 2009-10 के आसपास भी फेल हुआ, यहाँ पे दोबारा फेल हो रहा है. तो इट हैज बिकम अ कॉज ऑफ कंसर्न. ओके, तो two important type PSLV and GSLV, and in GSLV Mark II and GSLV Mark III. I hope आप लोगों को सबको ये समझ में आया है. Okay, now I'll take some doubts before I go to the sounding rockets. Let me take the doubts. Abhishek is asking, sir, PSLV XL क्यों? Why not GSLV for GTO? See, PSLV XL is a much smaller engine and is a more accurate engine when compared to GSLV. तो अगर आपके पास छोटा satellite launch करना है, it's something like if you have to make only 2 people travel, you'll use a car or you'll use a bus. You'll use a car. So PSLV is a car, GSLV is a bus, much higher capacity. तो अगर 2 ही लोगों को ट्रैवल करवाना है तो पूरा बस भेजने की जरूरत नहीं है ना, कार यूज करो. अप टू व्हाट हाइट अर्थ ग्रेविटी एग्जिस्ट? बेटा देखो, अर्थ का ग्रेविटी ना, देखो Gmm/r². तो r कितना भी बड़ा कर दो रहेगा ही जब तक r इंफिनिटी नहीं होता है. बट उसका इंपैक्ट कितनी देर तक रहता है वो आप गूगल कर सकते हैं. सर व्हाट इज द हाइट ऑफ GTO? देखो, GTO जियोस्टेशनरी ट्रांसफर ऑर्बिट इट्स अ एलिप्टिकल ऑर्बिट. तो इट विल हैव अ पेरिजी जो अर्थ के बहुत पास होगा, लो अर्थ ऑर्बिट वाले रेंज में होगा. It will have an apogee. Apogee should be at least 35786 kilometer. It should be more than that. 35786 kilometer or more than that. Now you have a question, sir. Please explain difference between specific impulse and impulse. Okay, let me give you the meaning of specific impulse and impulse. Okay, first of all, let's understand what is impulse. Impulse is force into time. देखो, सपोज आई पुट सम फोर्स, मैं इसको पुश कर रहा हूं, फोर्स कितने टाइम तक मैं फोर्स लगा रहा हूं, फोर्स इनटू दैट टाइम विल गिव मी इंपल्स. ओके, तो If time is very small and force is very high, तब भी specific impulse would be less. If force is very small but time is very high, तब भी impulse would be less. Both force and time should be balanced to get good impulse. So at higher levels, at large heights, you do not need a lot of thrust. You need some force which you should be able to play for longer period. So you need fuel which has better impulse. And 1 kg fuel आपको कितना impulse देगा is specific impulse. Specific impulse is impulse per unit mass of fuel. Impulse per unit mass of fuel. So specific impulse is highest for, let's say, hydrogen. It means hydrogen बहुत कम weight में भी आपको ज्यादा specific impulse देगा. Specific impulse is low for hydroxyl terminated polybutadiene. It means this solid fuel, per kg of solid fuel, you will not be able to get as much impulse when compared to per kg of this. So specific impulses per kg, impulses force into time. Fine. I hope मैंने आपका doubt clear किया है. Difference between impulse and specific impulse you have understood, I hope. Shivam is asking escape velocity वाला concept बता दीजिए. Should rocket carrying satellite need escape velocity to launch satellite? नहीं. Escape velocity is not. See, let's say this pen is there. If I throw this pen at some velocity, एक particular velocity होती है, then it will go beyond Earth's gravitational field. That is escape velocity. So if you are launching a rocket, if we launch it with a speed which will allow it to go beyond Earth's gravity, that's not needed, no? Escape velocity is not needed. We are saying that if all our fuel was solid fuel only, then this rocket may have got इतना सारा thrust से मिलता, it may have got what is called escape velocity that we do not want. That's why in the second stage we come up with liquid fuel, which will give it the control. What was copied Russian sir name which failed? Cryogenic engine. Initially when we developed GSLV Mark II, all the cryogenic engines came from Russia. अब देखो इंजन एक लॉन्च में एक इंजन यूज हो जाता है, तो जितने in few launches we used all the engines that came from Russia. Then we developed our own engine, own cryogenic engine 7.5, which is a reverse engineer version of the Russian engine, and that is creating problems for us. How engine fall down and which place this is falling? It won't fall in your house, don't worry. It falls in the water bodies generally. देखो, what would happen engines falling का फंडा ये होता है. Sriharikota से you launched a satellite. This satellite, you launched the rocket. This rocket, after reaching a particular height, will leave the first engine. It will fall in the water. Will leave the second engine. It will fall into water. Will leave the third engine. It will fall into water. Okay, and they are highly damaged while they are falling from the Earth's atmosphere. They face a lot of heat and all, and they get destroyed. Reusable engine we have not been able to develop. So far, all the engines that we use are only usable ones, but we are working towards developing reusable engine. Okay, we'll talk about reusable engine in the coming sections. Sir, what is S200 in? अरे वो name of the engine दिया हुआ है और कुछ नहीं. Understood, sir. As in physics, specific denotes a per unit mass. Yes, that is per unit mass. Impulse is specific impulse. विकास इंजन, लिक्विड इंजन, जो लिक्विड इंजन को नाम दिया है विकास इंजन. PSLV में जो सेकेंड स्टेज में लिक्विड इंजन यूज हो रहा था, दैट वाज विकास इंजन. ओके, नेम विकास इंजन, लाइक बस नाम दिया है. सर, इफ वी डेवलप आवर ओन टेक, देन व्हाई आर वी यूजिंग रशियन वन? The new tech that we have developed is a much bigger engine that was developed keeping in mind GSLV Mark III, not keeping in mind GSLV Mark II. So for GSLV Mark II, we're still using the older engines, which were reverse engineered version of the Russian engines. Okay, chaliye, let's go to the sounding rockets. Sounding rockets. देखो, दिवाली में आपने पटाखे चलाए हैं, रॉकेट दिवाली में? Is that rocket used for launching some satellite? No, that rocket just goes up, makes some noise, gives some light, right? Sounding rockets are also not something which are used for launching satellites. Sounding rockets are used for experimental purposes, testing purposes. Suppose we develop a new rocket, GSLV Mk III जब हम develop कर रहे थे तो उसका पहला engine बनाया. अब now we want to test the first engine. How will we test the first engine? We will use a sounding rocket mechanism where first engine will go up to 60 kilometers height and then will fall back. That is sounding rocket. So sounding rocket is not, rockets are generally used for launching a satellite, launching a spacecraft. Sounding rockets are not used for that purpose. मैं ये बोलता बस ये आवाज करते हैं. In reality these just आवाज नहीं करते, ये नई टेक्नोलॉजीज को टेस्ट करते हैं. They're also used for upper atmospheric studies to understand what is the moisture level, what is the temperature level at a height of 50 kilometers, at a height of 60 kilometers. How will you do that? You launch a rocket with some sensors in them. That rocket will go to that height and the sensors will measure the parameters and would come back. This is sounding rockets. When you're testing new technology, sounding rockets would be used. When you have to do upper atmospheric studies, sounding rockets would be used. When a country starts developing rockets, they start with sounding rockets. India's first rocket were sounding rockets that we got from France. I think एक France से आया था, एक US से आया था. The first rockets that we got, those were sounding rockets. Those were not used for launching satellites. हमारा पहला सैटेलाइट तो आर्यभट्ट 1975 में रशिया ने लॉन्च किया था. Whereas our first sounding rocket was launched in 1963 from Thumba. That was sounding rocket. So ISRO, other than having a PSLV, GSLV Mk II and GSLV Mk III series, it also has a Rohini series of rocket, which are the sounding rocket series. We also have Rohini series of rocket, which are called sounding rocket series. Atanu Chakravarti is saying hello, sir. Hello, Atanu. Okay, so this sounding rocket series, आप देखेंगे some basic details. Rohini series का RH is Rohini series. It can carry a weight of up to 10 kg, 60 kg, 100 kg. Altitude that it can go is 80, 160, 470. Now, you can understand 160 kilometer की height तक तो rocket launch भी नहीं कर सकते और satellite launch भी नहीं कर सकते. So they are not used for launching satellites. What is the purpose? Meteorology, aeronomy, and Thumba से या श्रीहरिकोटा से वो launch होते हैं. तो Rohini series of satellite, Rohini family of satellite is the satellite of sounding rockets. Now एक test हुआ था recently 2016 में, which is an example of how Rohini series was used for testing. This was air breathing propulsion experiment test. Now, as I have been telling you, Rohini series of satellites or sounding rockets are used for testing purpose. When we develop a new technology, we want to test it first. So, uska first stage we will test using Rohini series of satellites. So let's understand what this Rohini series of satellite and what this testing is. Do you know presently what is the agar hamara if our rocket along with all its payload is of 50,000 kg, let's say if it's of 50,000 kg, 80-90% of it is the fuel that we carry. Fuel is the most weight thing that we carry in our rocket. ये बात समझ में आई? Now, we not only carry fuel, we also carry oxidizing agent. For example, for cryogenic engine, you saw liquid hydrogen and liquid oxygen. In the same way, in HTBP, hydroxyl terminated polybutadiene, that we are using as solid fuel in the first stage, we add chemicals so that oxidizing agents are available. Oxygen is available. So we also have to send oxygen in our rockets. Now, where would most of the fuel used? Most of the fuel would be used on the lower heights, because that is the time when gravity is the highest. Most of the fuel would be used at that time. So most of the fuel would be used at that time. Most of the oxidizing agent would be used at that time. But in the lower stages, हम अर्थ के जब few kilometers तक जा रहे हैं, तब तो हवा में भी ऑक्सीजन अवेलेबल है ना. When we are going to a height of 40-50 kilometers, till that time in air we have oxygen available. So why are we carrying oxidizing agent? Can't we use oxygen from the air? Air breathing propulsion experiment. Breathe from the air. That is, आपका fuel जो burn हो रहा है, let it burn using oxygen from the air. Do not make it carry oxidizing agent. It will reduce the amount of weight that is being carried. Weight that is being carried will reduce if you start using oxygen from outside. But the problem is, rocket goes at very high speed. So if you want to use oxygen from outside, oxygen will flow at air would flow at very high speed, and in that high speed maintaining flame is difficult. आप दिया जलाते हो, बहुत तेज हवा चलती है, दिया बुझ जाता है ना. Maintaining flame at when oxygen is entering your device at a very high speed is challenging. So here in this experiment, for a few seconds, flame was maintained while breathing oxygen from outside. So abhi we haven't developed this whole engine as such, but this air breathing propulsion experiment was done by Rohini series, using Rohini series of rockets. Rohini 560 rocket use हुआ था. So see, a new technology that we are developing for experimental purpose, we used Rohini series of rocket called sounding rocket. Okay, so इसी में let's briefly understand scramjet and ramjet engine. Ramjet engine क्या होता है? Ramjet engine is an engine which takes in oxygen from outside, which takes in air from outside, slows down that air, and then burn the fuel using the oxygen from that air. Whereas in scramjet engine, we do not slow down this air. So here, what we are trying to develop, we are trying to develop the capability to have scramjet engine. Ramjet engines we already have. Our missiles, like Sukhoi missiles, have ramjet engine. Here we are trying to develop the capability of scramjet engine. In scramjet engine, the air would not be slowed down. We'll study these things in more detail when we are dealing with defense. But scramjet, ramjet ke beech mein, this experiment was basically an experiment to develop the capacity of scramjet engines. Okay, now let's go to the next topic. These are the three primary rockets that we have: the PSLV, GSLV Mk II, GSLV Mk III, and sounding rockets. But there are newer kind of rockets, newer kind of engines that is in the process of development. We will talk about those engines, those new things. Dekho, we have talked about cryogenic engine. A new or type of engine is also being developed, which is called semi-cryogenic engine. Cryogenic engine में क्या था? Both hydrogen and oxygen have to be kept at very low temperature. In semi-cryogenic engine, rather than using hydrogen as fuel, we use kerosene as fuel. Kerosene मिट्टी का तेल, but a much more purified version of kerosene, which is called ISRO. ISRO has developed a much more purified version of kerosene, which is called ISRO. Now, kerosene can remain liquid at room temperature. So kerosene does not have to be kept at cryogenic stage, very cold, very low temperature stage. Kerosene does not have to be kept at very low temperature. In that scenario, this engine becomes semi-cryogenic. Kerosene at room temperature and oxygen at minus 180 degree Celsius, oxygen at cryogenic stage. This is what is called semi-cryogenic engine. बात समझ में आई? तो let's compare cryogenic and semi-cryogenic engine a bit. In cryogenic engine, what will be the fuel? Liquid hydrogen. Here, ISRO. ISRO is basically kerosene का एक better version which has been developed by ISRO. Temperature, liquid hydrogen requires a temperature of minus 250 degrees Celsius, whereas kerosene can be stored at normal temperature. So it's a semi-cryogenic engine. Third, weight. Liquid hydrogen is heavier when compared to this engine. Specific impulse. Liquid hydrogen has better specific impulse. Specific impulse अच्छा है तो कहां पे यूज करोगे आप इसे? अपर स्टेज में. तो क्रायोजेनिक इंजन लिक्विड हाइड्रोजन वाला इज यूज्ड इन अपर स्टेज. थ्रस्ट टू वेट रेशियो. थ्रस्ट किसका ज्यादा है? सेमी क्रायोजेनिक इंजन का ज्यादा है. तो सेमी क्रायोजेनिक इंजन इज बीइंग डेवलप्ड फॉर लोअर स्टेजेस. जो सेकेंड स्टेज है लिक्विड स्टेज, उसको बदल के हम इस सेमी क्रायोजेनिक इंजन से इन द नेक्स्ट वर्जन्स वी वुड बी कमिंग अप विद सेमी क्रायोजेनिक इंजन. सेमी क्रायोजेनिक इंजन इज नॉट बीइंग डेवलप्ड फॉर अपर स्टेज. अपर स्टेज के लिए अभी भी क्रायोजेनिक इंजन है, बिकॉज लिक्विड, बिकॉज इन अपर स्टेज वी नीड फ्यूल विथ हायर स्पेसिफिक इंपल्स, एंड हाइड्रोजन हैज हायर स्पेसिफिक इंपल्स. Semi cryogenic engine is giving what? Better thrust. And what has better thrust? Where do we need more thrust? In the lower stages, first stage or second stage. So second stage is liquid stage. In the advanced satellites, we'll have this semi cryogenic stage. Understood? Clear? Now let's go to reusable rockets. अच्छा संजय जी पानी रख के गए थे, मैंने देखा नहीं, सॉरी अभी पीता हूँ. देखो अभी I have been telling you this, no, right now our PSLV goes, first engine falls, gets destroyed. While falling back from the space, from the atmosphere, all the friction and all destroys it. Second stage falls, gets destroyed. Third stage falls, gets destroyed. तो एक रॉकेट हम एक ही बार यूज कर पाते हैं. All the engines are used only once. But now understand the issue, understand the problem. Problem is this: suppose you have to travel from Delhi to Noida, and you are using a car which can be used only once. Will it not make your whole system very expensive? Here also, you're launching a satellite, but the rocket can only be used once. It becomes very expensive. What is important is we develop reusable rockets, the rocket that will be able to use again and again. The engines, they'll fall back, we will recover them, and we'll use them again in the next. The rocket falls back, we'll recover them, we'll use it again. Rocket falls back. Modular courses, economy, geography, अरे वाह, like वीडियोग्राफी टीम बहुत अच्छा काम कर रही है. ऐसे मार्केटिंग कर रहे हो ना. इसमें साइंस एंड टेक का मॉड्यूलर कोर्स नहीं है. अरे हटा दिया आपने. कुछ सेकंड के लिए चलाते हो क्या? अच्छा, ओके. They're doing something on YouTube, interesting things on YouTube. Come back to this. What were you saying? What we want is engine should be able to fall back, we should be able to recover it, and then use it in the next launch. जैसे कार को यूज करते हो, पैसेंजर को छोड़ा, वापस आई, दोबारा पैसेंजर चो. इसीलिए कार सस्ता पड़ रहा है ना, कार से ट्रैवल. इफ कार एक ही बार में खराब हो जाती, तो थिंक हाउ एक्सपेंसिव इट वुड हैव बीन. इवन इफ यू आर ट्रैवलिंग विद नैनो, यहां से नोएडा ट्रैवल करने का 2 लाख रुपए तो लग ही जाता. इफ कार्स वर यूजेबल ओनली वंस. तो द होल वर्ल्ड इज वर्किंग टुवर्ड्स this reusable launch vehicle. Till now we have several fully reusable suborbital system. Please note, not orbital system मतलब जो सैटेलाइट को लॉन्च कर सकता है. suborbital system ऊपर जाके नीचे आ जाता है. तो we have several, we have मतलब world has several fully reusable suborbital system and partially reusable orbital system. Partially reusable मतलब SpaceX has a rocket जिसका first stage reusable है, पर second stage अभी भी reusable नहीं है. SpaceX Falcon 9 has a reusable first stage and expendable second stage. India does not have a reusable first stage engine also. In fact, पहले SpaceX was trying to make even the second stage reusable, but now it has given up on it. It is developing a new rocket called SpaceX Starship. which will be fully reusable. The world is still moving towards this reusable things. Now, if ISRO is able to develop these reusable vehicles, these reusable rockets, its cost of launch will reduce by 70-80%. आज जिस चीज को लॉन्च करने में आपको 100 करोड़ रुपए लगते हैं, कल 20 करोड़ रुपए लगेंगे, if you are able to develop reusable vehicles. Several steps are being taken to develop reusable launch vehicle. For example, जब हमने experimental flight launch किया था ना, उसका 2014 में we launched an experimental flight for GSLV Mk III, जिसका फर्स्ट स्टेज इंजन टेस्ट किया था हमने. वहां पे we also tested our capability to recover the engine. मतलब while falling back एक पैराशूट खुल गया था ताकि वो इंजन धीरे धीरे गिरेगा and we would be able to recover it. But बहुत ज्यादा प्रोग्रेस अभी तक in developing reusable engine has not taken place. Fine. तो reusable engine roughly idea समझ में आया है reusable engine का. Now come to SSLV, small satellite launch vehicle. देखो अब right now the satellites that can be used for launching the rockets that can be used for launching satellites are PSLV, GSLV Mark II and GSLV Mark III. These are some things that we have. Now PSL, इसमें सबसे लेस पावरफुल कौन सा है? PSLV है. इतना डाउट क्यों होता है? सबसे कम पावरफुल PSLV है. नाउ PSLV में भी सबसे कम पावरफुल कौन सा है? PSLV कोर अलोन. PSLV CA से PSLV XL तक जाते हैं हम. The least powerful is PSLV core alone. But what weight can PSLV core alone carry to sun synchronous polar orbit or low Earth orbit? 1100 kg. Our smallest rocket can carry 1100 kg too. What if someone comes with a 100 kg satellite? What if someone comes with a 100 kg satellite and says, ISRO, launch it. I'll give you this much money. ISRO would say, let others also come. Let the weight go to around 1000 kg, then we'll launch. It's something like, do you know roadways buses? If 2 passengers will go and sit, they will not start. They will wait for more people to come and sit. In the same way, our rocket is capable of launching 1100 kg of satellite. If someone only comes with a 50 kg of satellite or 100 kg of satellite, ISRO will say, wait. Sawari bharne do. This becomes a delay. So the player who came to us for launching a satellite, if we ask them wait for 2 months, they'll say, I'll go to some other country, some other agency. Right? कई बार आपको बस में बिठा के 15 मिनट बैठे रह गए, बस नहीं चल रही, आप उतर के दूसरे बस में चढ़ जाते हो ना. Something like that would happen. Did you understand the problem? Delays for players who want to launch their satellite. But now, delay तो हो रहा है. There are other issues also. PSLV के असेंबली में बहुत टाइम लगता है और बहुत सारे इंजीनियर्स लगते हैं. महीनों लग जाते हैं, 1-2 महीने लग जाते हैं और 60-70 इंजीनियर्स लगे रहते हैं. So we wanted to develop a smaller rocket which will be able to carry smaller weight, which could be assembled easily, which will be assembled quickly. ऐसे महीने लग रहे, 1-2 दिन में assemble हो जाए. We wanted to develop something like that, and which should also be affordable, less costly. Towards that, we have developed what is called SSLV, Small Satellite Launch Vehicle. It is the smallest vehicle at 110 ton mass. India का smallest launch vehicle है ये. It can be assembled only in 72 hours. PSLV takes 70 days to assemble. It can be assembled in 3 days. It only requires 6 people, whereas PSLV required around 60 people for assembly. Its cost of assembly is only rupees 30 crores. It's a 3-stage engine. PSLV was 4-stage engine. SSLV is a 3-stage engine. All solid. All the stages in SSLV are solid. Payload capacity of 500 kg to 500 km planar orbit and 300 kg to SSPO. So to sun synchronous polar orbit, how much can it carry? 300 kgs. So it's like a cab that we have developed. PSLV was a bus. SSLV is a cab. जो 2-3 लोग भी आए तो वो जा पाए, फास्ट सर्विस मिल पाए, कम कॉस्ट में असेंबल हो पाए. Need, global demand for launch of small satellites are going up. इसका first developmental flight is scheduled to happen in April 2022. That's why it has been in news regularly. In April 2022, you would see it would be used to launch microsat, a satellite, a small satellite. It would be used for launching that. SSLV, small satellite launch vehicle. समझ में आ रहा है? I'm hoping. Okay, let's go to the next. ISRO plans for nuclear energy use in space. अभी हमने nuclear energy पढ़ा नहीं है. Like for pre-com mains batch we have definitely studied, but in science and technology also we will study nuclear energy. But nuclear energy is becoming more and more stable with changing technologies and all. Nuclear energy is improving. Now the problem is in these engines, PSLV के engines, GSLV के engines जो आपने देखे, were we using nuclear energy in them? No, we were using chemical fuels. HTPB, hydroxyl terminated polybutadiene, UMDH, hydrogen. We're using these fuels. We're not using nuclear energy. Okay, ठीक है, यहाँ तो use भी नहीं कर सकते because we need something which can give us thrust. And thrust देने के लिए क्या होता है ना, आपका exhaust होना चाहिए कुछ. जब exhaust निकलता है तभी आपको धक्का मिलता है. But in some situations we need nuclear. We can use other forms of energy. जैसे जब satellite rotate हो रहा है, so it has to send some signal on Earth. It will need some energy to send that signal. Generally we use solar energy for that purpose. When a spacecraft is moving away and away from Earth, it is going to study other parts of the universe. It may happen, it may be going away from sun, तो sunlight reach करना भी मुश्किल हो जाएगा. So solar energy may not be available for that rocket, for that spacecraft. So we basically nuclear energy in a very small mass can provide a lot of energy and can basically solve a number of our problems. But and initially during the Cold War era, use of nuclear energy was started. Initially USA also launched the satellite. In 1961 US transit mission was launched using nuclear energy. But उसके बाद USSR ने भी 2 dozen nuclear powered space object launch किए. But use of nuclear energy for launching rockets were given up for a number of reasons. There were budgetary constraints, there were complicated design issues, there were progress in other sources of energy, and also the possibility of escalation of Cold War. Cold War, like आप अपने spacecraft वगैरह सब में nuclear energy, nuclear devices डाल के ऊपर भेज रहे हो, it may have become a cause of concern. For all these reasons, the idea of using nuclear energy in space programs were given up. Currently, very few space agencies have developed and are using nuclear powered rovers. For example, US का Perseverance है, जो कि nuclear powered rover है, but otherwise very few space agencies are using nuclear powered rovers. But with changes in technology, it is believed that now nuclear energy का use हो सकता है. For example, now more and more players are venturing into space. Sunlight is not always available, especially if you are behind Earth. Sunlight would not be available. Sun और Earth के उसमें आप Earth के इस तरफ हो तो sunlight would not be available. When you are moving further away from Earth to study Pluto and all, sunlight would not be available. In that case, having nuclear energy could be crucial. Nuclear energy could be beneficial. So increasing number of programs leads to more requirement of nuclear energy. Advancement in nuclear energy sector, reliability and maintenance and all those things would have improved. Weight of nuclear fuel is much lesser. For missions which are very far away from sun, solar power is not an option. They also provide flexible launch windows, like you do not have to worry about sunlight kab aayega, kab nahi aayega, and all. Okay, therefore, because this nuclear energy thing is improving, UR Rao Satellite Center of ISRO have called for proposals for three-phase development of 100-watt radioisotope thermoelectric generator RTGs to be used in space sector. तो इसरो का एक एजेंसी है URSC. It has invited proposals from various companies to develop what? To develop radioisotope. Radioisotope is nuclear thermoelectric generators. What is radioisotope thermoelectric generators? These are devices. RTGs क्या होते हैं? RTGs are devices which use heat generated by nuclear energy to make electricity. But how? They will use certain substances जिनके एक एंड पे अगर टेम्परेचर ज्यादा है और एक एंड पे टेम्परेचर कम है. If they have high temperature on one side and low temperature on other side, they will generate voltage difference and thus would generate electricity. So radioisotope thermoelectric generators is something that is being developed, that is planned to be developed to use nuclear energy in the space sector. देखो nuclear energy एक तो वो है आप हीट जनरेट करो, फिर वाटर को स्टीम में कन्वर्ट करो, टरबाइन को रोटेट करो. स्पेसक्राफ्ट में वो सब पॉसिबल नहीं होगा. तो स्पेसक्राफ्ट में हीट जनरेट हुआ एंड हीट डिफरेंस की वजह से जो वोल्टेज जनरेट होता है उससे डेवलप इलेक्ट्रिसिटी. दैट वुड बी द की एस्पेक्ट. ओके, तो यहां पे आप देखेंगे रेडियो आइसोटोप थर्मल RTG के बारे में मैंने थोड़ा सा और समझाया. दे आर लाइट वेट कॉम्पैक्ट स्पेसक्राफ्ट पावर जनरेटर्स. तो स्पेस के लिए पावर जनरेटर्स होते हैं. दे प्रोवाइड इलेक्ट्रिक पावर यूजिंग heat from nuclear reaction. The large difference in temperature between the hot fuel and the cold environment of space is applied across special solid state metallic conjunction called thermocouples. It is these thermocouples which, when there is temperature variation from one end to other end, they generate electricity. So ISRO के UR Rao Center has called for generation or development of this RTG. It has called for proposals for the development of RTG in various phases. Okay, so these are various. So what I have tried to do, मैंने जो नए रॉकेट्स बन रहे हैं, नए इंजन्स बन रहे हैं, वो भी बताया है. जो प्रपोजल्स डाले गए, जो RTG बनाने का प्रपोजल है, वो भी बताया है. तो all current affairs related to rockets of India have been done. Basics have been done. Current affairs have been done. Okay, let's now solve some questions. Tiklup Gupta is saying, sir, let us stop for today. क्यों भाई? थक गए क्या? हमारी वीडियोग्राफी टीम थकी है कि नहीं? मैडम आप थकी हो? नहीं, आपको तो कुछ सुनना है नहीं, बैठे रहते हो, थकोगे कैसे? आप लोग थक गए? अच्छा, टेल मी दिस, कैन यू गिव हाफ एन आवर मोर? 30 मिनट्स और पढ़ सकते हो तो बताओ, यस बोलो, मैं 30 मिनट्स में क्वेश्चंस करवाता हूं. Can we study for 30 more minutes? Say yes or no. Yes if you want to continue, no if you do not want to. No, you do not want to. Nalaik, Anmol. Yes, yes. अच्छा, नो वाले को एक ही बंदा नो 5 बार नहीं लिखना भाई, नलायक लोगों। अच्छा, नो बहुत ज्यादा आ गए, चलिए ठीक है, विल स्टॉप हियर टुडे। We'll stop here today. Tomorrow we'll continue from this. First, tomorrow at 9:30, first thing that we'll do is we'll start solving questions. ठीक है, इसके क्वेश्चंस करेंगे और उसके आगे फिर पढ़ेंगे। ठीक है, टुमारो इज 31st, हम जितना कर पा रहे हैं ठीक है। फर्स्ट के बाद से ना मैं 5-6 दिन लूंगा बजट इकोनॉमिक सर्वे ऑफ इंडिया खत्म करने के लिए। I do not want to delay it when we start economy. I want to finish budget and economic survey of India in the first 5-6 days only. Okay, चलिए, तो I'll see you tomorrow guys, tomorrow at 9:30. Tomorrow at 9:30 we will solve these questions and we would continue with the space section of science and technology. I hope आप लोगों को अच्छा लगा है, तो अच्छा लगा है तो प्लीज इसे लाइक भी कर दीजिएगा और अपने दोस्तों के साथ भी शेयर कर लीजिएगा। एंड I'll also do this tomorrow। अच्छा, कल की क्लास तो लाइव नहीं है। हाँ, आगे भी जो भी सब्जेक्ट शुरू होंगे, जैसे एंटायर इकोनॉमिक सर्वे ऑफ इंडिया बजट, विल डू इट ऑन यूट्यूब लाइव। जो भी सब्जेक्ट शुरू होंगे, फर्स्ट फ्यू क्लासेस वुड बी लाइव, so that we can display the quality of